Good afternoon. Welcome to the 2020 IEEE International Seminar on Women in Circuit and System (WiCAS), organized by IEEE Joint MTT AP CAS Joint Chapter Islamabad. I am Dr. Nusharwan Shoaib, the chair of the chapter, and also working as associate professor at Research Institute for Microwave and Millimeter Wave Studies (RIMMS) at National University of Science and Technology, Islamabad, Pakistan. So we are organizing this event. There's a bit background behind this event, and the background is regarding the Women in Circuit System WiCAS initiative by IEEE Circuit and System Society in this year. And the goal of this initiative is to increase the female leaders in local chapters, including CAS chapters, also to increase the female CAS members and encourage Pakistani women to join engineering. The idea is to encourage women to be leaders in engineering, especially in RF and microwave area, as women are the key, play a key role in the development of human progress or in the success of a nation. And in this era of time, both male and female leaders actually develop and also add towards the success of our nation. So our local our local female members and international colleagues will join us in this webinar. We will have the technical talks as well as the talks from our panelists. So moving ahead, we have two keynote speakers in this webinar, Dr. Rabia from Boston University, USA, and Dr. Wala from Lahore, University of Management Sciences, LUMS. The title of the talks is How We Will Communicate and Who is Listening, the Future of Wireless Communication by Dr. Rabia, and Ultra Low Power System on Chip for Next Generation Wearable Biomedical Devices by Dr. Wala. In addition to these keynote speakers, we have an interesting panel discussion. We have 5 women in our panelists. They are well recognized in their RF community. And engineering, Dr. Seema Latif belongs to School of Electrical Engineering and NUST, Pakistan. Dr. Sana Qadir and Dr. Mahira also belong to the same school. Miss Mara Islam belongs to RIMMS, NUST, and Miss Akila Sagar belongs to Links Foundation in Italy. So we will have these 5 panelists that will join us during the Women Engineering panel session to give their thoughts and also share their stories. This is the overview of the seminar agenda. So after my talk, I will give the floor to Dr. Umar Khan, who is currently the HOD of the RIMMS-NUST. He will give a brief presentation on the RIMMS. Then I will give another presentation on the chapter activities, our history of the chapter and the activities we have conducted so far. We will have 2 keynote talks, one before the panel discussion and one after the panel discussion. And then the ceremony will be closed by our principal, Dr. Hamad Mahmood Chima, who will give his remarks at the end of this webinar. At the end, I would like to acknowledge IEEE Circuit and System Society for financially supporting us and taking this very interesting and very need of the time initiative of IEEE CAS WiCAS initiative to support and to encourage the women in Pakistan and also in other countries as well to become the leaders in the area of wire and microwave, especially in circuits and systems. So that is the welcome remarks from my side. Now I will request Dr. Umar Khan to proceed ahead and start his presentation. Thank you. Okay, so we have Dr. Umar with us. Dr. Umar, can you please share your screen?
Right, so yeah, my screen is shared.
Yes, Dr. Umar, please proceed ahead. Thank you.
Okay. Assalamu alaikum, everyone. A very warm welcome to all of you to the Research Institute for Microwave and Millimeter Wave Studies, which is hosting the today's seminar on women in circuit and systems. That is being done in collaboration with IEEE chapter that we have here. So the seminar is about the Circuit and System Society. And I mean, we have today some of the two very prominent and very good speakers from the same society, and which will be giving us very informative lectures on the topic of their research. So we have Dr. Rabia and we have Dr. Wala from LUMS. And after that, we have a very nice panelist discussion from some of our own graduates as well as the faculty members at RIMMS and NUST. So let me briefly tell you about what is NUST. So here you can see a complete picture of NUST. It's a very beautiful campus spreading almost over an area of 4 square kilometers with many different institutes. So it is it has more than 1,500 faculty members, and there are multiple around 49 different master's and undergraduate programs as well as PhD programs in all areas, including engineering, basic sciences, as well as in business studies. So we are RIMMS. You can see this is the institute on the right bottom side. So here we are offering the graduate program in millimeter wave, RF and microwave. So NUST is basically in Pakistan is a top ranking university, and according to QS ranking, it is 355th in the world. Over the past 3 years, it has improved 82 positions, and it is among top 60 under 50 years old universities. In the electrical and electronic engineering domain, its position stands somewhere around between 200 to 250, and it is 83rd in Asia according to QS ranking. And in engineering technology, it is the top university in Pakistan. Coming to the RIMMS, which is today's hosting this event, which is a constituent college of NUST. We offer a graduate program in electrical engineering with a focus on RF and microwave, and our area of expertise and the studies and the curriculum that encompass the topics include fundamental and applied electromagnetics, microwave system design, antenna theory design, RF measurements, and RFIC design. We host some of the very good facilities for our students who are studying here and carrying out research. So we have a very good facility for the antenna measurement. We have VNS, which can measure up to 40 gigahertz. Then we have an anechoic chamber with a near field scanner as well as a far field scanner, which can do antenna measurements for the radiation efficiency and pattern measurement, gain measurements of antenna up to 40 gigahertz. The near field scanner can measure an antenna with a maximum dimension of up to 8 feet by 8 feet. So we have a very good EMC and I lab as well. There we can do the EMC and compliance testing, as well as this is being used for research. We have developed very good collaboration with the international community as well. Like by virtue of this area, our students regularly visit the Dutch Meteorological Institute, and they are doing their thesis there as well. We have micro research lab where we have the function generators, VNAs, and other accessories to carry out research as well as the studies in the area of microwave. We have in-house very good PCB fabrication lab, which we are actually trying to increase with time so that we can in-house fabrication facility for typical microwave circuits up to the expand. So one of the machine is the LPKF, which give us the rapid prototyping of our RF PCBs. So with this kind of facilities, with this program, this is a very good program for students who wish to continue in the area of RF and microwaves. Now, since this event, I hope the talks of the professor as the panel discussion will be very informative for all of our students as well as all the community of students and other researchers who are today joining the session. It will be equally good for all the male as well as the female student, but the particular focus for this session is about how to inspire young female students all across the globe, and specifically in Pakistan and in NUST, to pursue this area. So we will be having some of the success stories, some of the very good female faculty members, as well as our graduates who are taking leading positions in the industry as well as in the academia. So this session is about to inspire our young female students as well. I'm very happy to report that since fall 2016, 145 students have admitted in our MS program, and out of that, more than 30% are female students in RIMS. And I hope that this number will continue to increase, and we will be having like a 50-50% ratio in due course of time. We have a very vibrant IEEE chapter, and we take all the opportunity under the platform of IEEE for the dissemination of knowledge in this area of RF and microwave, as well as RF circuit design and other encompassing areas within electrical engineering. So because of our efforts, we have achieved certain awards of IEEE, and we continue to work under this IEEE chapter for the wider benefit of the society in the dissemination of the knowledge. And in doing so, I mean, today's session is also one of the same thing. And we have already been doing many of the similar kind of workshop and conferences. Unfortunately, because of the COVID, we are not able to do this thing this time physically, like we used to do earlier. But I hope as the situation is back to normal, we'll be looking forward to have these kind of professors and you people as well at RIMS, so that we can have much better interaction. But at the same time, I hope that today's event will be very informative for all of us, especially for the female students. And I hope we will have some good and interesting talk in this area. Thank you very much.
Thank you very much, Dr. Umar, for your very informative talk. Now the next talk is on the IEEE Joint Chapter. So I will be presenting that talk. So let me share my screen. Okay, welcome back to this seminar. So after introduction presentation by Dr. Umar regarding the RIMS, now I will give you a detailed presentation on the IEEE Joint Chapter, the platform that we have started for the benefit of the humanity and the community. So our chapter has as a journey, a history. It started back in 2016 when we have no technical chapter in Pakistan, and there's no common platform in Pakistan to hold such activities or to use the platform of the well-known societies of RF and microwave to conduct activities for betterment of the students, faculty members, and researchers in Pakistan, and also to have a strong research collaborations with other universities abroad as well. So having this aim in mind, we have developed our first IEEE chapter in 2017 that was approved by IEEE Islamabad in 2017 and approved by IEEE in October 2017. The chapter initially has two societies, MTT and APA Society, Microthree Technique Antenna Propagation Society, and it was extended to include the IEEE Electromagnetic Compatibility Society in August 2018. And as Dr. Umar has mentioned in his presentation, we also have the Electromagnetic Compatibility Interference course and lab as well at NUST that will be considered as a national asset and share this facility with all the faculty members, students from other parts of the Pakistan. Especially our focus is to give the opportunities to students from underprivileged areas and of Pakistan to come ahead and use their talent for the betterment of community. And this this initiative was proven to be very successful because we received very positive remarks from the students, from the faculty members, especially from the underprivileged areas, and also from the international community, that this platform has provided a bridge between the Pakistan and international community in terms of research collaboration, in terms of academic collaboration, in terms of knowledge sharing effort. So chapter was further extended in October 2020 to include the IEEE Circuit and System Society, and today's webinar is basically financially sponsored by IEEE Circuit and System Society with a particular aim of encouraging women in this area, as we consider women as our very important asset for our society, for any society, and for the progress of a nation. We have more than 50 memberships so far as per December 2019 statistics. I will also share in other presentations as well in future for updated statistics as well. Our mostly members are regular members, and we also have some senior members as well. We have some students members as well, and here still we need to improve in this area to encourage more students to join these societies. And so far, we have conducted more than 60 national international workshops, seminars under the umbrella of this chapter. So these are the official of this chapter. I'm chairing the chapter. Dr. Hamad Chima is a co-chair. Dr. Umar Khan is trainer. Dr. Zubair is secretary. And Ms. Mara Islam is our female focal person. And we try to include more female in our official list so that we have a balance. And we also encourage women to lead in these chapters and also in other parts of women in engineering. So I start a very quick overview of the activities that we have conducted so far. This is the activity that I typically show in my presentation very often because this is our first effort towards the ask all the faculty members, students, and industry rep to come under one platform and share the take advantage of this knowledge sharing platform. So this was the first international computer simulation technology workshop. CST is a software that is used for the antenna design and other design RF micro designs as well. So we have conducted this webinar in September 2017. We have the Professor Hadidi and her assistant from Germany to visit us and give us a 3 days long workshop, and we have seen that this workshop was attended by many students and faculty members from different parts of the country to witness this event and to take maximum advantage of from this event. And the success of this event gave us a lot of encourage to conduct many other events with full zeal. Afterwards, we also take maximum advantage from distinguished lecture program. This is a special program from East Society of RF Microwave and also other societies of engineering community that basically send fully funded professor, researcher, well-known professors to the various countries to deliver the talks and to meet with the local community. So we have conducted this seminar in November 2018 with Professor Yahya from Royal Military College, Canada. Is shown here is also currently the president-elect from IEEE Antenna Propagation Society. So it's also well attended event. You can see here as well. We have also conducted another DL event in November 2019. So this is our regular event each year. And in this event, we asked three professors, Professor Fangi and Professor Mathis and Professor Nunu to visit us. Unfortunately, afterwards, we are unable to conduct the face-to-face events, but we have taken maximum advantage of distinguished lecture program during the COVID and arranged a webinar series that I will show you after a few minutes. In addition, we have carried on miscellaneous activities. I will not go into detail of each activity, but just to give an overview of the activities we have conducted, especially in 2019, when we have the face-to-face possibility. There are several events we have conducted on antennas, on IoT, on the student reunion as well, on automation and connected driving in cars from international speakers. These are few other highlighted here. Events are shown, especially IEEE EMC workshop that we will conduct each year. And this is our flagship workshop that in addition to DL program, we also conduct this workshop each year for students, faculty members, also for the industry as well. We also conduct some other events as well regarding the how to write a manuscript. This is an LATIC workshop, some other workshop on disaster management, nano scale healthcare systems, 5G on voice sense system. Or we also, this is also very interesting event that we have conducted is pro bono student design workshop, in which apart from their students technical activities, our purpose was to improve their design skills and so that they can incorporate in their thesis and research. This is also the EMC workshop for 2018. This event was particularly very interesting event that we are conducting in 2019 is about the RF design competition. And in this competition, we basically request the students to develop the super design receivers from the ICs that we have provided. And it was also well attended by the students. These are the three winners circuits that I'm showing you here. And here you can see our postgraduate students have produced very well managed and very well prepared designs that convert an RF signal to a low frequency through various steps. So developing the PCB boards using the IC is a hard job, and there are several challenges that actually you face when you design such kind of networks. And from the student, expecting students to develop these kind of circuits and seeing from Pakistan is very, very encouraging. So we are planning to repeat this event in 2021 as well. Due to pandemic, we are unable to conduct in 2020, and we hope that more students will join us in this event. Then we have carried out an outreach talk, because to get a success in the community should know what's going on under these societies. What are the purpose of the society? What are the different societies? What are their platform? What are the opportunities? So there are several talks we conducted, both national and international. This is the talk that was conducted in Auckland University of Technology in New Zealand in May 2019. We have conducted a serious outreach talk at various universities in Pakistan, including University of Engineering Technology WA campus, RIFA International University Islamabad, Institute of Space Technology Islamabad, UET Texla, Air University, and High Tech University. These were the few universities over which we have conducted the talks during our past tenure. We are also planning to conduct more face-to-face and physical, face-to-face and virtual activities to encourage students to join this area, which is a very much needed area, and we need the human resource in this area. So students are actually the ones that can contribute positively in this area. We also have a strong networking collaboration from this platform, and you can see many professors here. I'm sure if you are belong to RFMI community, you know this professor very well. He's Professor Balanis, whose antenna and provocation book that we follow both at undergraduate and graduate level is one of the very famous professor, and also the writer for the book. We have Professor Ron Han from MIT, Professor Raj Mitra from USA, and Professor Shavi from Canada. So this platform also gives us a good opportunity to connect with the professor and do the collaboration, and we have published a paper with them as well. Now I give the focus on online education initiative that we have carried out during COVID-19 pandemic, and this was a very hard time for us during this period, that we are unable to conduct the face-to-face activities. But we have converted this COVID-19 pandemic into an opportunity, and have taken several online education initiatives, including YouTube channel that we have make. This is a different YouTube channel as compared to the traditional YouTube channel, because on this YouTube channel we have published a very detailed videos of the facilities that we have at RIMS, including the anechoic chamber, in network analyzer, device characterization, internal characterization, and gain measurements, and so on and so forth, anechoic chamber. And these detailed videos are basically gives an overview to the students that can learn how to use these facilities without coming to NUST or to the university due to the pandemic. So this was an interesting initiative, was well appreciated by the students. And this is not just for the student of NUST. These videos are public, and they can any student from Pakistan internationally can access these videos. And we are seeing that these videos have many views so far. So this means students and faculty members are actually seeing these videos to take the knowledge of how to use an equipment during this pandemic process. In addition to this, we have also carried out a webinar series, and this is very important because due to pandemic, we are unable to conduct face-to-face events. So we move completely to the virtual world, and we have organized many webinars, 23 webinars so far, from very well-known professors in the RF and micro community. And most of them are also distinguished lecturer professors from IEEE Microtuning Technique or Internet Propagation Society and Electromagnetic Compatibility Society. And we are very happy to see that the response from the professors and researchers are very encouraging and very welcoming. So all of these professors have given a detailed our talks under the umbrella of our chapter in this webinar series, and all these talks are also available at our YouTube channel. So we have conducted 23 webinars so far, and this is not an end. We have still many webinars lined up in our webinar series that we will conduct very soon in December and upcoming months as well. So for each information, you have to visit the website, our website, RIMMS.NUST.edu.pk, for announcement of new webinars regarding the RF and microwave community. As Dr. Umar has mentioned, we received a recognition from the international community as well for our events that were conducted under the umbrella of IEEE Joint Chapter Islamabad. So we received our 2020 IEEE APS Outstanding Chapter Award. We received 2020 EMC Chapter of the Year Award. We also received the Outstanding Chapter from IEEE MTTS Society. So all societies have given us the best chapter awards, and these awards are very competitive to win because there are many proposals. But again, if you are hardworking, you're dedicated, and we're very dedicated volunteers, team of volunteers that actually are available to make this knowledge sharing platform for the betterment of the community. So regarding our future plans, one of our very key future plan is to initiate the Pakistan's first RF and microwave conference, and this is our key goal that we have to do. This will be the first dedicated RF and microwave conference ever in Pakistan. So you have seen many RF and microwave conferences in other countries as well, and we would like to do this in Pakistan, in Islamabad. And this conference will be titled at First IEEE International Conference on Microwave Antennas and Circuits, also in short form is known as ICMAC 2021. This will be held in most probably November 2021. We will share the details on our website, and we would like you to join this conference, hopefully in the face-to-face mode or in a hybrid mode. And this will be a key opportunity for us as well to gather the RF community in Pakistan and also bring the international community to Pakistan for maximum benefit in terms of research and collaboration. One of the key aim of our chapter is to encourage women to lead in RF and microwave area, and this is a very important need of the time. Women are actually the asset of any nation, and if any nation would like to make a success in this era, women has to work together with men with equal opportunities. So we also would like to encourage more women to come to engineering, especially in RF and microwave area, and to bring a positive change to the community. Our another initiative is to expand the chapter to other cities of Pakistan, Karachi and Lahore, and I really feel happy to see that the few professors from Lahore are trying to establish our joint chapter in Lahore as well, and which is a very good thing that these efforts are contagious, that what we are doing in one city of Pakistan has an effect in several other cities of Pakistan as well. So we first start with the major cities and then go to the other cities as well. We also have a very strong support from IEEE Islamabad section as well. They always support our activities and always help us to carry out very successful events in the past. The establishment of student chapter is also one of our goal, and as you can see in the first slide that I mentioned that we need to increase the student involvement in this chapter, and for this purpose we need to establish dedicated student chapters and dedicated student societies as well, which we are actually working on. And the last but not the least is to continue the online education. As very important is to webinars and recorded videos. Here I would like to mention that this online education initiative was proven to be very successful because many professors who in normal condition unable to travel to Pakistan due to their health and other commitments, they gave the talks online, and this is an excellent opportunity that the community in Pakistan has to witness the state-of-the-art research with the help of professors from of international repute. So this initiative was proven to be very successful. Apart from these spiritual plans, I request all of you to come up with any proposal or collaboration information that you need or that would like to make any joint event. So please send us an email. My email are flash here. And here I would like to thank all my volunteers, all my team. It's not just one person effort, is an effort of a team. I would like to thank all my team, all my volunteers, all my students and others, colleagues who make this these activities very successful. I hope in today's event you will enjoy the various talks and the discussion. So my last message is to stay safe and stay healthy. This pandemic has already caused a lot of damage to various societies, and it's our responsibility to keep the safe distance, wear the mask and no handshake. So please stay safe and stay healthy. And with this, I would like to thank you for your attention for this talk. And we now proceed over the next talk, which is from Dr. Wala from Lahore University of Management Science, Lahore University of Management Sciences, and she is our one of the key speakers. So now I proceed to that presentation, and thank you very much. Okay, welcome back. So next talk is from Dr. Wala Salim Mustafa from Lahore University of Management Sciences. A few words about the Dr. Wala. So Dr. Wala received the bachelor's degree from Computer Engineering Department, Yarmouk University, Jordan in 2009, and the master degree in Microsystem Engineering and PhD degree in Interdisciplinary Program from Master Institute of Science and Technology, Abu Dhabi, UAE in 2012 and 2016. respectively. In 2013, she joined Test Chip Integration Team, Global Foundries, Dresden University as a test chip intern, where she performed quality assurance tests on advanced nodes for DFM. She developed a low-energy body area network transceiver for binaural hearing aid for long-time continuous monitoring. Since 2016, she has been with the Electrical Engineering Department, Lahore University of Management Sciences, Pakistan, where she is currently serving as assistant professor. Her current research interests include ultra-low power wearable devices and system-on-chip design for portable biomedical devices. Dr. Sada was the recipient of IEEE International Symposium on Circuit System 2015 Best Paper Award in the WiCAS track and the ISCS 2015 runner-up Best Student Paper Award. So, without any further delay, I start the presentation from Dr. Wala, and she will also be available with us for questions and comments.
Assalamu alaikum. Thank you for inviting me today for this talk. My talk is titled as Ultra Low Power Systems on Chip for Next Generation Wearables Biomedical Devices. So I first want to introduce my research area and interests. So I work on wearable devices for health monitoring, such as glucose monitoring and other vital signals. I work on humans' gait and motion for fall detection and prediction. I work also on portable devices for on-hospital support. And I also interested in point-of-care applications and lab-on-chip. So in summary, I work on the next generation of biomedical systems. This is an brief outline of my talk. So I will first start with the background and motivation. Then I will discuss the challenges in the wearable environment. And after that, I will go into the details of two examples of projects that I am working on, the non-invasive glucose monitoring and depth of anesthesia prediction from EEG signal. And finally, I will summarize my talk with the key points. So why we are interested in the wearable devices, why they are so important? This is because 1/3 of the deaths in the world are caused by chronic diseases. And these diseases require continuous monitoring and treatment. So the wearable devices, they will provide us with solution to monitor the patients and help keep track of their conditions and treat them accordingly, and hopefully reduce the number of the deaths caused by these diseases. So I'll just give you an example here of a case of a patient that when we are continuously monitoring their glucose level during one full day. You can see that there are quite variations in this glucose values. So if the patient came and he measured his glucose level at point A and B in time, they will think, oh, my glucose level are in the normal range, so I don't need to take extra medication, or I can eat more sweet or do something that might be health rescuing himself and might be cause bad consequence for the patient. So therefore we can see the importance of continuous monitoring to give us a realistic picture of the patient's health condition and how we should treat it accordingly. Therefore, the continuous monitoring is an essential for current diseases. We look forward from the wearable devices to provide us with certain requirements. So they should be safe, they should be convenient for the patient, and they don't cause the patient any irritation, and they should not be annoying with extra wires and connections or bulky that they are heavy to carry. We also, one important thing of them, that we want them to be reliable, that we can depend on them and they are accurate, so that the doctors and the patient, they both can trust them. And they should also be secure, so the patient information should not be distributed with others. The main thing we require from them is also to be energy efficient, to allow continuous monitoring with 24/7 real-time processing of the data. So they should have a long battery life, so the patient is not annoyed being changing their battery every few hours or every day. This is going to be annoying for the user of these devices. So these are, again, summarize the requirements of the wearable devices: the patient comfort, signal quality, and accuracy of the device. The device should be small to not disturb the patient life, and should not be also very clear, so don't cause a stigma for the patient. And we want it to be energy efficient to allow long life of the battery. So the solution is basically to use integrated circuit design with low power techniques to allow miniaturized medical device. And as we can see here in this picture, this is small in a form of plaster. We can see that we are incorporating a medical device that measuring the ECG signal of the patient, and he can view the data on his mobile. Now, what are the common signal types that we typically use in the wearable device? There is the first type is contact-based, where the electrodes are used to acquire the signals. So we have the ECG signal that's used to describe the cardiovascular function of the heart. We have the EEG signal which is describing the neurological function of the brain, and we have the EMG signal that reflects the muscle movements. All of these are useful and give us very important information about the patient conditions, and they have been widely used for detection of multiple diseases and disorders. We have another type which is also contactless, that is basically an optical detection of signals from the patient, and we call it the PPG signal. That basically very useful in measuring the heart rate, the oxygen saturation in the blood, and any other type of cardiovascular diseases such as arrhythmias and others. It can be also useful for the COVID-19 patients for measuring their SpO2, respiratory rate, and heart rate variability. So, is this sounds so much easy? Indeed, it's not. If you look at this picture, which showing us description of these physiological signals, you can see that they are lying in a low frequency range, very small amplitude in the microvolt or very few millivolts, and the PPG signal, which is measured through current, it's also in the microamp range. So they are very small amplitude that we need to carefully amplify them. And the main challenge that they are also in the low frequency range, which is full of noises in this area. The flicker noise that's happening in the CMOS devices and offset of the amplifiers. We will come to discuss them in details. The other main challenge is the processing of these physiological systems. So, okay, I acquired them nicely and they are here with me. What should I do with them? We need to process them in order to detect the abnormalities or to measure the glucose value or do any useful data that we need to extract from the signal. This requires processing of enormous data. So where should I process this data? I have two choices. Either I process it in a remote station and therefore I need to continuously transmit this data through the Bluetooth to the remote station, or I process these data on chip, on sensor directly without need to transmit, and I only can transmit the output that I extract from the signal. So if I want to compare those two options, and here we are discussing basically this for one application of the EEG transmission to detect the depth of anesthesia, you can see here that if I have to continuously transmit the EEG signal to the remote station, I will require 27 more times power than in the fully on-chip processing, and I only transmit the final output of this device. So you can see that fully on-chip processing reduces a lot of power, and that is important for an energy-efficient wearable device. So how the story begins? How did we start with the wearable electronic? It begins back in 1962 with the first commercial Holter monitor for monitoring the heart functionality. And as you can see here, this is the Norman Holter who created this device, carrying this large and big device on his back to demonstrate the working of his device. And you can see here in this other picture the bulky devices for wearable devices. And the story began here, and they start to shrink down in size by time. So you can see now they are integrating them in the clothes, or they are integrating them in a form of flexible electronics and new gadgets and smartwatches that they are used and they are available currently in the market. But in order to increase their clinical impact and make them more used and more accessible for patients, we need to have the devices achieve these functionalities. So we need to acquire the biosignal with a good quality. We need to be able to extract the features, whether they are temporal or spectral features, and then we need to classify the abnormal functionality versus normal, or we need to do regression function in certain applications, and finally we need to be able to display the results for the patients or monitor them in case of any critical condition. So now I will go and discuss in details with you the examples of my projects describing wearable biomedical devices, and the first is the non-invasive glucose monitoring. So why it is important to discuss the glucose monitoring? This is because the diabetes is basically affecting around 1 in 11 adults worldwide, which is equivalent to around 415 million people worldwide. This also linked to an increased risk of cardiovascular and other diseases. So we need to do something about it. The conventional methods for measuring the glucose level is the finger prick test, which is basically annoying for frequent pricking. And if you ask most of the patient, they would love to get rid from this device, but it's the only device that is, let's call it, affordable for the patient. However, the strips that they require to change every time, they are required costly. And the other option is to do laboratory tests, medical labs, but this is requires drawing the blood from the patient, and the results will take hours or days, and obviously it's more costly than the previous method. So this motivates us to look for a non-invasive device. Now, the non-invasive glucose monitoring, it will hopefully provide us an accurate method. It will allow us to continuously monitor the sugar level in the blood, and we therefore need to have a minimum power and area design. So this is the final look that we aim to have a shape of an earring and the small that the patient can use frequently on and or even continuously without feeling annoyance or discomfort. So before we go forward, let's describe the PPG signal that we are using, basically this technology for extracting the glucose level from the blood. Basically, PPG is a non-invasive optical method that used to detect changes in the blood volume. So basically, the different wavelengths that used in this technology is basically are being absorbed in the skin and in the body composition from a fat and muscle and bones differently, and therefore it's being detected with a different level of absorptions. So you can see here, if you are familiar with this device that's called pulse oximetry. Basically in this device we have a light source that's LED and a photo detector that detects the absorbed light, the light that's being transmitted or reflected from back from the skin, and we are going to use this light to extract important information about the patient. So this is a typical shape of a PPG signal, but that is basically composed of a DC component that is caused by the bone and muscle and tissue, fixed tissue of the human finger, and then we have a small AC component that is riding on top of this DC value, and the frequency of the signal reflects the frequency of the heart rate of the patient. So basically there are two basic techniques for getting the PPG signal. The first one is called transmission type, that where basically we have the LED on one side and the photodiode on the other side of the patient. So we are detecting the transmitted light through the patient finger. And the other type is called the reflection, where we basically, the photodiode and the LEDs, they are both on the same side, and we basically are detecting the reflected light. So we are using two types of LEDs, the infrared LED and the red LED. And this is for the reason is that both of them are affected differently by the blood. So if the blood or the color of the hemoglobin molecules in the blood are being oxygenated versus non-oxygenated, they have different absorption level. And therefore we can detect how much oxygen we have in the blood, and this is give us the value of the SpO2 that we measure through the pulse oximetry. So this figure shows us how is the value of the absorption spectra of the hemoglobin versus non-hemoglobin, or oxygenated versus non-oxygenated hemoglobin, how they are affected by the different colors or the different wavelengths of the signal, and therefore we can detect how much we have oxygen in the blood, and this is very useful for the respiratory disease patients. And nowadays it's very important for COVID-19 patients to keep track how much oxygen they have in their blood. So if we are using the infrared in our PPG signal, we may also refer to it as NIR spectroscopy. So basically we have a near infrared light source that is basically any value in the range of 750 to 2500 nanometer that can be used to shine the light, and therefore we call it NIR spectroscopy. So basically it's very useful in multiple applications for the food analysis, agriculture, and medical and pharmaceutical and chemical products. So basically, as you can see here, we are using for the glucose monitoring, we are using this technology with a wavelength of 940 nanometer. We are sending the light and then detecting it through the photodiode. Why we have selected this wavelength? Because this wavelength, it's being minimally absorbed by the water composition in the blood, and it's maximally absorbed by the glucose. So you can see here that the glucose molecules, as shown in this describing picture, that they are being absorbed by the glucose molecules. In order to verify this, we have performed experiment in our lab. We basically had a tube that's having different, we are changing the sugar concentration in this tube, and we are measuring the signal that's being detected by the photodiode. We can see here our measured results that showing with increasing glucose concentration in this solution, we are getting more absorption of our light, and therefore the voltage that's been measured is reducing accordingly. So this verify our theory about the wavelength of 940 nanometer and its effect, how it's affected by the glucose level. So in order to realize our system, we started with the first prototype on FPGA and a PCB board and displaying our signal on the mobile phone and on the computer. This was published and demonstrated as well in CAS conference, International Symposium of Circuit and System 2019. So we have used a single photodiode and a single LED of wavelength 940 nanometer integrated in this finger clip, and then we are acquiring the PPG signal through this PCB board, and we are processing our data on FPGA. However, this device is not compact, and it's also required complex operation with having multiple parts of the system separated. The second prototype of our system, we have integrated our system entirely on chip, and we have basically improved the performance compared to the first version with using minimum estimation errors achieved, and we are rejecting a DC current of up to 20 microamp from the PPG signal or the current that's been detected by this photodiode. And the beauty of this application is that we are only using a single LED, and usually in the PPG signal, the LED is the most power hungry device because it requires a driving current in the range of tens of milliamps, and that's basically the main source of power consumption. However, this device is still not optimized. It consumes large power, and we have been measuring through the finger, which is not an optimal site for measurement for a continuous monitoring. We have worked on improving our system in our third prototype that was published in Asian Solid State Circuit Conference 2020. And it also uses single LED. We have improved our LED driver to achieve low power. We have improved our accuracy compared to the second and the first prototype. And we achieved much, around 10 times less power consumption. And we have basically developed a fully differential readout circuit with the chopping to reduce the noise. I will describe the details. This is the die photo of our system. So if I want to discuss the details of our proposed glucose monitoring system, so we have used a low power LED driver because the LED driver is the most power consuming part. We have used fully differential readout circuit with chopping to decrease the noise. We have a low pass filter that's filtering our signal at around 10 Hertz, followed by a 10-bit SAR ADC. And then we have the glucose prediction processor, which is the digital processing unit. And we have automatic LED and DAC controls for adjusting the brightness of the LED and the DC rejection. Why do we need DC rejection? We mentioned that the PPG signal or the car has basically a large DC component that is going to basically saturate our transimpedance amplifier. So we first need to get rid from this DC component with the help of current DACs that they are used for subtraction of the DC component. So we will be left only here at this point at the entrance of the transimpedance amplifier with the AC component that is basically carrying the useful information for us. So this is the schematic of our PPG readout. We have the current subtraction DACs. We have TIA with chopping to reduce the 1/F noise and the offset of this amplifier because they are happening at low frequency that is coming in the range or in the bandwidth of the PPG signal. So we need to get rid from the noise. We are also allowing a variable gain in order to allow wide range of current PPG signal that's going to be dependent on the patient who's using it because every human has different body composition. And then we have a low pass filter cutting at 10 Hertz, which is quite challenging to implement on chip in order to have very low corner. Therefore, we have implemented this resistor with a pseudo PMOS in order to reduce the area and the noise. Now this is our proposed LED driver that's basically allowing different values of the current that can be changing from 12 milliamp until 120 milliamp in order to change the brightness of the LED, and this is being generated through a current mirroring from a 1 milliamp current source on chip. In order also to reduce the LED driver power, we need a very small duty cycle, that's 0.125%. And in order to generate that, we have implemented it through clock division and frequency dividers. Now, if I move on to the processing of the PPG signal to extract the glucose, the main part first is to extract the right features that they will reflect the effect of the glucose level on the PPG signal. So basically we have selected our features based on rubber methods where we evaluate all the possible combinations of the features from the feature set that we have, and then we selected the best combination that gives us the best result and the highest accuracy of glucose readings. So the features that we have studied are the logarithmic energy feature, Kessler-Tiger energy feature, spectral entropy feature, and autoregression model feature. So basically, we have the PPG signal. We divided it into frames, each frame of a length of 1 second, and the window has 10 frames. Each window has a 10 frames, and some features we computed them on a frame level, and the others are computed on the entire window level. So the total of features that we have studied are 14 features, and with the help of the rubber method, we selected only 10 features out of them, and the features are being extracted from a filtered PPG signal through a moving average filter to get rid from the noise. And during the implementation, we have applied power and clock gating optimization techniques in order to reduce the energy requirement of the system. So this is the basic block diagram of our glucose estimation processor. We have the moving average filters, and then we are computing our features, the Kayser-Teeger log energy feature and the entropy feature, and we are finding the statistical measures of these features. Now, for Kayser-Teeger feature, we basically looked into the conventional method to implement it on chip, but it requires storing all the frames in the memory, and that's going to be huge area requirement. So we propose to store only 3 most recent samples. That is going to allow us to utilize the pipelining operation, and therefore we were able to reduce on-chip memory requirements by more than 70% if we were going to be using the conventional approach. However, this requires slight increase in the clock frequency by around 3 times. Now, for the other statistical measures, the interquartile range and the skewness, they require computation of the median and the 25th and 75th percentiles. So we have optimized the implementation in order to reduce the power consumption and utilize as much as possible from the shared components between those 2 features. And this helps us in reducing the gate count by 50% compared to standard method. And it also reduces the overall gate count to around 23 K. Now, for order to find the glucose value from these features, we have utilized nonlinear Gaussian medium support vector regression that is basically required to implementation of a complex nonlinear operation, and therefore mainly it relies on an exponential function that we have simplified into a piecewise linear operation by dividing it into a different region, and this helps significantly in reducing the gate count by around 43%. And this does not have much error, it's only cost us 1.3% error, and it consumes 102.8 microwatt within 0.8 microjoule per operation. So if we look at the measurement result of this device, the entire device consumes 186 microwatt, which is around 8 times less power compared to our previous prototype. You can see here the measured noise with chopping and without chopping. We have around 57 reduction in the input referred integrated noise, which is a huge achievement. However, this required an increase in the power consumption of the TIA by around 15%. If we want to see how our system is performing with respect to the power consumption and varying the frequency of switching of the LED, we can see that with chopping, we are achieving a higher dynamic range and allowing our system to process more wider values of the input range with only 32 microwatt power for our entire PPG readout circuit. If here I just want to demonstrate for you a PPG readout measurement and glucose readings for 3 subjects, we can see that here the different PPG signals, we are extracting the features, and through the glucose prediction processor, we are measuring their values with a quite high accuracy with a maximum of around 7 mg per dl for the glucose values. So here this is a standard measurement tool for glucose value that's called the Clark grid. It's showing that all our measurement for our patients is basically lying within the range in the area of A and B, which they are considered clinically acceptable values. And here we are comparing our measured versus reference values with a very high of correlation with a 0.955 R square and mean absolute error difference of 5.2% at a pulsing frequency of 100 Hz of our LED. So this measurement was done for 80 patients. This table compares our system with the state of the art. So basically we have a minimum error and with a very less power consumption compared to the others. And we have demonstrated this on using 200 patients. Some of them, 120 of them were used for training and 80 were used for the testing. Now, I want to move on to describe our other example of the detection of depth of anesthesia from the EEG signal. Now, if we want to say why this is important, because the awareness during general anesthesia and the surgeries occur 1 to 2 times per 1,000 patients. And this causes basically very bad effects on the patients. So, and this happens due to the underdose of anesthesia. So we have around 20,000 to 40,000 cases per year. And these are even more higher incidences in children. And this leaves patients with a trauma and very bad side effects that they occur after surgery. And on the other hand, too deep anesthesia leads to complications that they might cause also liver damage, stroke, lungs infection, and even death in some patients. So the first prototype to detect the depth of anesthesia from the EEG signal is basically using a patient-specific approach. And it utilizes the EEG signal with multi-level decision tree to decide the depth of the anesthesia. We have used a database that's basically combo available online, and it is basically very limited number of patients in that database. So then we have moved to collaboration with a technical university in Munich, Germany. And then we developed our local collaborators at the Children's Hospital Lahore to get more patients' data. So in our conference, this was demonstrated in a biomedical circuit and system conference 2018. We have achieved low detection accuracy and due to the limited number of the patient. Therefore, again, we move to our recording. So these images are taken through our recording process at the Children's Hospital Lahore. We have recorded for 50 patients using emotive EEG headset. So the patients were in the age of 4 months to 15 years. So those patients, they were with the less serious cases in order to avoid any complications for those patients. And our second prototype, we improved our implementation and we have tested on 45 patients. So we have utilized a decision tree, fine decision tree approach, and that approach was basically utilizing 5 features to estimate the depth of the anesthesia with good classification accuracy and sensitivity of 91.9% and specificity of 92.5% with a latency of 1 second. This is basically the layout of this system, and here we are demonstrating the operation of our system with using a decision tree that was used in the first prototype compared with the fine decision tree in the second prototype with much higher accuracy compared to the previous prototype that's having multiple false positives. Now, our third prototype, we used more number of patients. We tested it on 95 patients. We improved our system. We included an analog front end and more optimized feature set. And we have utilized bagging tree machine learning algorithms, and that helps to further improve our accuracy to 95.4%. Here we are demonstrating the case of a child patient having an age of 10 years during a surgery of hernia. We can see that the quite accurate detection of our system. So if I want to summarize my talk, I have discussed about the challenges in the wearable devices, the advantages of them allowing a continuous monitoring and detection of the diseases. They can also be used in the suppression of chronic diseases such as seizure if they are combined with stimulation functionality. We have discussed the importance of optimizing the feature selection and the feature extraction process. We need to make sure that the features are being extracted and implemented on chip using energy and area efficient implementation. Beside or equivalently important, the machine learning classification and regression tool, it should also be area and energy efficient. We should have highest sensitivity and specificity or minimum error in case of the regression. We can also combine this closed loop system to alarm the patient on their mobile phones or to provide a stimulation or a neurofeedback functionality and a recording for further discussion or to display for the physician. Thank you for your time and open for question and answers.
Thank you very much for a very interesting talk by Dr. Wala. So now I will take the speaker online as well, so that we may ask questions to the speaker. We have few questions already lined up. So we have to wait for a couple of minutes now. Assalamu alaikum, Dr. Wala. Dr. Wala, your mic is off. Can you please turn on your mic?
Hello?
Yes, yes. Assalamu alaikum, Dr. Wala. Thank you very much for joining us. So we will now start the question answer session,
Yes.
and I will ask you question one by one. Just give me a couple of seconds. Okay. So thank you very much for your very interesting talk, and we have few questions lined up. So the first question is, how much FPGA programming is required in RF field?
In our field, it's not just about FPGA programming, but we use the code, the similar code of Verilog coding for both on-chip creating for digital systems, and also if we first try it on FPGA, it can be used the same code. So we require it for the digital side of the signal processing. We use the Verilog coding. First, you can try it if you are making the first prototype on FPGA, and then you can convert it on chip.
Right, right. The second question is, can you please comment on the process that has been followed to take such non-invasive CGM devices to the market? Are there clinical studies and regulatory approvals required?
Yeah, so I mean, taking a medical device to the market takes long process. You first need to verify, I mean, once you create a first prototype of the device and verify it on the number of patients. And also, even if you want to do at the university level, any clinical test or test that involve human subjects, you need to have an IRB approvals. And that's also another process. Once you verified all your device and you are sure about it, and you make a product version of it, because sometimes the products are bigger size. So if you make a product size and you verify it on the patients, and you need to take approvals. For example, there are local approvals and there is the international and the FDA approvals. So that process takes time, and you can see that there is more into the research. A lot of products take several years from the research until they reach to the market. So it takes time to do this.
Right. So another question is, can you please share the steps of typical IC design cycle followed for such biomedical designs? What is the typical time for each step and which tools are used for each?
Yes. So, for example, if I want to make any biomedical device, first I need to identify what problem I am going to tackle. For example, if I want to measure, similar to my example, that project that we are working, the glucose non-invasive monitoring. So first we identify that we want to work on this problem. We make a literature review to see what has been done in this regard, what are the good approaches to follow, and what things that we don't want to go through them. Then we identify that we want to use the optical method through the PPG signal. Once you do that, you also need to develop your algorithm. You might verify it in the MATLAB. If you find any public database that basically show you, like, give you the PPG waveforms and the glucose reading that correspond to it. But unfortunately, it's not available publicly. So we have created our own prototype, the first version with the PCB board and the FPGA, in order to record the PPG signal and the glucose values for many subjects. And then we start working on the algorithm on the MATLAB tool. And once we verify, okay, the results are good, let's move on chip now. Then you need to convert that MATLAB code into a digital signal processing, and we need to convert the PCB board into IC design. With that design at the transistor level, we are using cadence tools. So we need to do the simulations, and then you need to create the layout for the chip and combine both the analog and the digital. And once they are the design are ready, you verified using all the tools for verification. you need basically to send your design to the fabrication through a foundry, and we are using TSMC 180 nanometer. So we are in contact with the one company that's called the Muse Semiconductor. So we send to them our design, and then after 2 to 3 months, they send us, they ship the chip to us. And then we basically create a board to connect the chip on it. And then we do the measurement to verify that the chip is working. So the process, minimum, all this process takes at least 1 to 1.5 years to from the start until you have a chip ready that is measured. Okay, does this answer?
Right. Yeah. Thank you very much. I think you clearly mentioned all the process and the time. So there's another question regarding your work is for non-invasive measurements. Do we have effects of fat tissues because it varies from body to body?
Yeah, so that is it might affect, and therefore, like when you want to make a generalized or a device that works for other, you need to make in your testing data that different type of subjects. Like you need to take male and female. You need to take young children, and you need to take adults. So you should not only target on a small sub or a subset of the society and say, okay, this will work for everyone. Like, for example, when we did in the depth of the anesthesia measurement device, it's not sufficient to just test on adults or test on a one type of the anesthetic agent and say that this will work for everyone, especially if you are using a machine learning type. So that needs larger data set with the different variations in order to give you a good result. So the fat is also a part of the body composition, and for example, it will affect how much your electrode connectivity or how much light is going to be absorbed in the body if you are using an optical method. So obviously it has effect, and usually when you design your amplifier, that is first taking the signal from these electrodes or from the optical photodiode, you need to make it a variable gain so that you adjust according to the levels that are arriving from the electrode or from the photodiode. So in order to have more it works more with a different variation of the patient. So we don't give it just a single gain value that might saturate or might be so low for other patients.
Yes, indeed. The working with biomedical devices is always very challenging because it's a multi-dimensional problem, and there are a lot of parameters that you have to consider while designing. Also, it takes a lot of time for approvals and clinical studies, and also it's also challenging to get the data as well. So I really appreciate your work and your research group work that you are doing in our university in LUMS in Pakistan. So Dr. Vala, since you know this webinar is also one of the aim of this webinar is also to encourage women to come in circuit system area. So seeing your profile, you started your journey from Jordan, then to UAE, then to Germany, and then to Pakistan. So it's a multi-country journey. I think is a very good example. So can you please share your journey, your experience with our students, or especially our female students? So how you enter in this area and what are the different challenges and opportunities you have gone through while going through various different countries?
Yes. So basically, when I was my undergrad in Jordan, I was studying computer engineering. That was quite different from what I am doing now. But then when I wanted to start my MS degree, I was more interested into changing a little bit the field. So I opted to go for microelectronics, to dig deep inside and see how the they are really working the computer, like with the small chips inside, how they are working. So I had my master in the microelectronic field, and I was too much liking it. And it's always evolving field. Every day you are learning a new thing, and this technology is like you feel you're working on the cutting edge technology. During my PhD as well, I continued in the same field. So now I have been working in this field for 10 years. It's every day fascinating and enjoyable working on this one. Now I joined LUMS in 2016, and that time there was not so many opportunities in this field, let's say at least locally here in Pakistan. But since that time, things have started to change. There is a lot of interest are being developed into circuit design and into this field. Many big companies are showing interest, like Analog Devices, Intel. There are also local opportunities and companies like Limbrumulan here in Lahore. And there is NISCOM also is interested in opening, or I think they have already opened a section for the circuit design, and many others as well. Now, the beauty of this field for the woman is basically that it does not require a field work, not like a power systems where they have to have power stations and doing all that. That might be difficult for women to do. But working on the circuit design and in this field, it's mostly going to be the opportunities that they are available in the field, in the research and development field. So for example, us and university labs, we are always looking for any trained people in this field. We will be very happy to find anyone who can work in this field and just hire them. Similarly, I think now in NUST, there is a work on this in the past. Other universities in Pakistan are also going into this field. So I really advise all the females who are interested into this field not to be intimidated by or worried that there is no opportunities. No, the opportunities are there. You just need to look for them, and you need to develop and make yourself skilled in this field, and everybody will be liking to hire you and to give you a job. So this field is really interesting. You, especially in the research and development, is not going to be very difficult for females to do this job as others field. It might be one of the easiest fields in the electrical engineering for women.
Yes, thank you very much for your very motivating comments. And I think indeed it's a very good opportunity for female students as well to join this area, not just RFIC design, but also any area of engineering, because women are the real asset of a nation. And if we would like to progress in this time, so we have to, or women have to come on the front line and lead the various societies and research groups and the research areas. So
yeah, I just want I mean, I know maybe we all like women to do an all type of engineering, but why I was just mentioning this, because I know women when they have family, they worry where I will leave my children if I go to a field job or something like that. So that becomes very difficult for them. So I encourage them that this is not going to require you any field work or anything difficult that will make balancing between your family and your work a tough thing. So this will be easier, hopefully, for you, inshallah.
yeah, right. So as since you are a faculty member and in Pakistan, so can you please share maybe a brief message for, especially for the faculty members of female faculty members of Pakistan, that how they engage their students or they engage other faculty members to join this area? Apart from few, already you have mentioned few steps as well, or maybe one-liner or two-liner comment for the faculty members.
Yeah, and basically we have a lot who go for graduate studies, but we don't have much who is coming back into this field, who are coming back to Pakistan. So this is an evolving field that there are many opportunities are coming in the near future that I really advise anybody who, especially the females who are interested, you have higher chances of being hired even compared to the male because we want, so I am the only female faculty in my department. So we are always welcoming to have any good candidate, female candidate that they want to hire them, they want to give them the responsibilities, but unfortunately the applications don't come. So that's why there are a lot of chance for you if you really develop yourself and have been showing your potential to do the research and to be a faculty member. You are always welcome.
Yes, right, and I'm very sure with the time and the events like this and the people like you, the trend will change, and I'm very hopeful in the future. You and us and many universities in Pakistan will receive good. We will have good faculty members, female faculty members, in our faculty team as well. So with this, I would like to thank you very much for Dr. Wala. So for your very interesting talk and very motivating comments for the female students and faculty member. And I hope that we will remain in connection and carry out these activities in the future as well, because these are the platform actually that encourage women and also men and women both to contribute positively to the society. And you people are also one of the very good example in front of them so that they can follow. So thank you very much for your talk.
Thank you so much for inviting me today, and wish all the best for our female students, and just stay motivated and you will achieve all your goals. Thank you.
Thank you. Sure. Thank you very much, Dr. Wala, for joining us. Now I move to the next session, which will be at 4 o'clock. Will be the panel discussion of women engineering. We have 5 panelists on board, 3 from School of Electrical Engineering, NUST, and 1 from RIMMS, and 1 from will be joining us from Links Foundation, Italy. So we'll start at 4 o'clock. For this panel discussion, it will be an interactive discussion between the different panelists to share their journey and their ideas on how they can encourage the women and the female students to come in this area and lead. So stay tuned. See you after at 4 o'clock. Thank you very much.
Assalamu alaikum, sir.
Assalamu alaikum.
Walaikum salam. Assalamu alaikum everyone. कैसे हैं आप सब?
Good evening, ladies and gentlemen. My name is Myra Islam, and I am assistant professor at Research Institute for Micro.
Excuse me, Ms. Mara, please wait a couple of seconds. Thank you.
Yes, sir.
Okay, Ms. Farah, please proceed ahead with the panel discussion. You are live now. Thank you. Ms. Farah, you have to turn on your mic. आप सब लोगों को अपने mic on करने पड़ेंगे. Thank you.
Good evening, ladies and gentlemen. My name is Myra and I am assistant at Research Institute of Microwave and Nuclear Studies in NUST. I have been associated with teaching since 2010, and during this tenure, I have taught various subjects including microwave engineering, basic electronics, and instrumentation and measurements. Currently, I am also pursuing my PhD in electrical engineering. It is my great pleasure both to participate in this panel discussion with our worthy guests and to welcome you all to this event. Before I move on towards our worthy panelists, it's noteworthy to mention that 52% of the population of Pakistan is female. Out of this 52%, only 24% constitute the female workforce. And out of this 24%, only 10% women are working in the field of engineering. Keeping in mind, we have today invited 4 of our very accomplished females working in the domain of circuits and systems to share with us their example and their experience. This is a very diverse panel, and we will be discussing the role women are playing in various fields, including research and development, entrepreneurship, and academia. We will also be talking about the challenges they are facing in this field. Among us, we have Dr. Seema Latif. Dr. Seema has done her PhD from University of Manchester. She is also HOD Research, School of Electrical Engineering and Computer Science, NUST, and also founder of Avas AI Tech. Then we have with us Dr. Sana Kadir. Dr. Sana Kadir has done her PhD from International Islamic University, Malaysia. In her portfolio, she has experience related to academia as well as to industry. We also have with us today Dr. Mohera. Dr. Mohera has recently came back to Pakistan from China. She has done a PhD from Jiangsu University, China, and has also recently joined back NUST as an assistant professor in SEEDS. Then we have with us Ms. Akila Sagir. Ms. Akila Sagir is working at Links Foundation, Italy. She is a researcher there and was a graduate of our MS program. She is also pursuing a PhD from Cyprus. So without further ado, I would like to ask my first question with Ms. Akila. So Ms. Akila, could you please share your experience, how you got into the field of engineering and what motivated you to pursue your PhD in this field?
Assalamu alaikum, everyone. Well, the most reason to start engineering was my father. He motivated me to pursue telecom engineering from ComSets, and then I did not dream of coming this far. As we all know that it's not easy for a female to work then I started my master's from RIMMS in 2011, and I was among the second batch. And thanks to my friends who at that time, we had little knowledge of RF at that time, but once we were enrolled in RIMMS, we got exposure to a lot of interesting fields that, like, even RF has so many branches that we were not aware of it, but once we were in RIMMS, we got the chance to explore those ideas, and then I continued with electromagnetic compatibility at first, and then I'm doing my PhD from Cyprus, Frederick University, and I'm working on reconfigurable filter designing. And it's very interesting to see how much RF contributes to the scientific world, to our world, and it's very interesting. And also because I also started a job here in Italy in January, and here I'm working on antenna designing, which is also a very major part of RF and microwave. And it has been a great, let's say, curve of learning, and I'm very happy to be a part of RF and microwave, and I'm happy to be leading or helping females out in this domain.
Thank you, Ms. Akila, for sharing your knowledge gathering journey with us. Now, I would like to request Dr. Mohera to share her experience in the field and how she started her PhD in the field of microwave engineering and how she got the opportunity to go to China to pursue her PhD. Dr. Mohera, probably your mic is mute.
Sorry.
Can you please check?
Assalamu alaikum. So why I did my PhD? So the question arises because I was doing undergrad from NUST, and at that time I used to see the PhD faculty. They had a great stature in our society, and the respect they used to get. And also my mother and father, they are very encouraging in terms of education, and my mother used to say that I want you to pursue PhD in future, but I didn't thought about it that I didn't think about it that I will go to this domain further. And my father encouraged me to first of all join engineering. I'm the first engineer girl engineer in my family, and again he encouraged me to do masters. I was doing job at that time in NRTC, National Radio and Telecommunication Corporation. It is under Ministry of Defense, and at that time I got very hands-on experience in these devices like antennas and devices related to RF and microwave. So my interest developed, and also I started MS in the same field from RIMMS. So the interest developed on, and when I got this opportunity of PhD, there is a program. There used to be a program in NUST that was a faculty development program. I learned about it and I applied and I got the opportunity. And I'm really thankful to NUST for selecting me, and all these things together, they just made me to do PhD, and Alhamdulillah I finished now. And I have also joined CAS as an assistant professor.
Thank you.
So that's all.
Thank you. Now I'll move on towards our third panelist, that is Dr. Sana. Dr. Sana, what motivated you to apply at NUST, since you have your educational background from Malaysia, and then in 2019 you came back to Pakistan and have joined NUST. So what motivated you to join NUST as an assistant professor in the field of engineering?
Assalamu alaikum. First, I'd like to say thank you for inviting me to join this panel. The short answer is to your question. Basically, I had heard that NUST is the best university in Pakistan. So before I left Malaysia, I think my father was pushing me to apply for a position, and I actually wanted to take some time off, but he was encouraging me. He found the addis also, and he really pushed me towards it. The other thing is that I think that overall my background has been very in an international environment, and in that respect, I think I have a lot to offer. What I have learned and from my experiences, and I think that NUST is one of the best places that I can contribute most effectively. So that's the whole answer.
Thank you, Dr. Sana. Now I'll move towards our fourth panelist, Dr. Seema. Dr. Seema, you have also recently won the Best Innovator of the University Award in 2019. So I would like to ask that how was your experience going from going towards research and entrepreneurship? How was your experience, and how did you move towards the entrepreneurship in your career?
Thank you, Myra, for the introduction, and thank you for inviting me. So my journey is a bit long. I did my PhD in 2010 from University of Manchester, and then I joined NUST as assistant professor. I was doing research with my students, with my master's students, with my PhD students. But at certain point, I was feeling that something is missing. I was not contented with the progress I am making. Yes, I was progressing in terms of research, but my research was not of any use. So at that time, I started thinking towards making the commercial application of my research. It was in 2013 that I visited one of the autism resource centers in Pakistan with my sister. She is a psychologist, and she was dropping her CVs at various autism resource centers. So I visited one of the autism resource centers in Islamabad, and when I saw the conditions of children over there and the parents, I felt that our research is of no use if we are not helping them. So at that particular time, I started thinking towards how can I help these children. Actually, my PhD in artificial intelligence, and now we know that AI is applicable in each and every area of research, or you can say in every field. So then I started working on autism and how can I help them. So it was early 2014 when I came up with a project, and I asked one of my MS students to start working on that. So there, he has done some groundwork, and then we started working on that. It was in 2016 that there was some sort of prototype, or you can say proof of concept, that I was able to show to someone. But all that development requires huge amount of funding, which at that particular time no funding agency was offering, because every research funding was particularly purely for research, not for commercial development. There was a UK aid program by the name of ILM Ideas. I applied there. It was from a NUST perspective. Actually, though that ILM Idea, they have some program that they asked NUST Technology Incubation Center to take part in, and there I pitched my project and I got selected from there. And that was the first time I felt, okay, so my work is of some worth, because there was a huge panel who evaluated my work at that particular time. After that, I applied for funding from HEC. HEC has a technology development fund program. That was the first call for that particular program, and I applied for the same project. And Alhamdulillah, I got funding from that as well. So that was the time that changed my course altogether. I would say the course of my life as well, because that was the time when I started feeling accomplished, that now I am doing something for the community. Now my research is of some worth. So yeah, from 2017, I particularly started working as an entrepreneur. Then I formed my startup in 2018. And Alhamdulillah, we are doing projects. My autism project is also live, and it is being utilized by more than 300 users, not only in Pakistan, but international. And we have filed patents and copyrights on that particular software. We are continuously working on its improvements, and we are also working on some other projects. So that's my journey.
Thank you, Dr. Seema, for sharing your experience. The experience and the path you have taken is not only inspiring for the females of our society, but also for all the male colleagues and researchers who are working in this domain. So it must be challenging shifting from the research towards entrepreneurship. So now I would like to ask all of you one by one that what are the challenges you have faced during this journey? So Dr. Seema, can you please share that what were the difficulties you faced during the commercialization of your research projects, and what were the challenges you faced and how you overcome them?
Okay, so when we talk about research and entrepreneurship, both are different ball games. Research is because you are sitting in front of a laptop in your own room, you are doing your research, you are programming and stuff. you're disconnected with the environment. But once you enter the entrepreneurship, I would say it's not easy. You are exposed to world now. Um, your work is exposed to world now for its practical usage. So there's a difference between the research that we do for publishing paper that is going to be there, that is theoretical knowledge. But if we go for commercialization, that means that is the practical application of our work. So yes, there are a lot of challenges. The first challenge that I faced was mentorship. Uh, because I was incubated at NUST Technology Incubation Center. Initially, I faced few challenges over there, but then NUST has a very strong bond with their faculty, and we continuously keep on giving our feedback. And now, Alhamdulillah, they have a very good mentorship program. I have learned a lot from their mentorship program. From time to time, they call us for different mentoring and stuff. The second challenge I faced was commitment from the industry, because you are from academia. They know that our research side is very good, but from business perspective, from financial modeling, or from business model canvas and stuff, they think that we are not that strong. So we need to have one person in our team who is looking after the business side. And that's true as well, because I don't know about forecasting, about my financial projections. Then I had to have someone on my team who looks after all these financials or business aspects. So industry commitment was another thing. And third thing was funding, because initially you need funds to prepare, to develop the product. Commercializations comes after it. So once you have a prototype, once you have a commercial product, you show it to the customers or your clients, and then they are going to buy it. So now Pakistani research landscape and entrepreneurship or funding landscape has been evolving. HEC is giving funds for entrepreneurship for startups. Ignite is giving funds for startups, and even NUST is supporting startups. They have formalized a whole policy. So yes, from time to time we are facing challenges, but the good thing is things are coming along, and they are helping the new entrepreneurs, the young generation, to come towards entrepreneurship.
So what do you think, what further changes should the higher education or universities should introduce to make the environment more friendly for the young researchers, so that this gap that you faced during your research and then coming towards commercialization can be filled and it can be overcome? So what do you suggest, Jane? What are the changes you suggest?
Okay, so I will talk about not a specific university. I will talk as a whole, because there are so many things that we are practicing at NUST, but there are other universities who are not following such practices. So first one is that we need to add entrepreneurship and related subjects in our curriculum. Yes, entrepreneurship is a mandatory subject, but it's just a 2 credit hour in which students don't gain any practical knowledge. So we need some practical knowledge along with the theoretical knowledges. Secondly, business modeling for non-domain students. That is again one of the seen that, like, if we have a computer science graduate or a graduate from electronics department, but he does not have any knowledge of how to make business case or how to make financial projections of their project if they're pitching somewhere for venture capitalist or for funding. So that is the basic thing that they require. So they need to take at least one course on that particular thing. So we can add these courses as minors in our curriculum. Mentorship is the third thing. We need to arrange more talks to motivate our students. we need to arrange talks from the young entrepreneurs, not the aged one, because there's a gap between, you can say, the generation gap. I would rather say that if a younger student hears something from almost of his age, they understand more. And the fourth thing is industry exposure. So if they go to startups, they see their culture, what challenges they are facing, only then they are going to be able to have a better idea what is entrepreneurship is and how they can overcome the challenges if they enter this particular phase.
Thank you, Dr. Seema. I would like to ask Dr. Sana. She has worked in Malaysia and she has been associated with the academia there and then the industry there. So do you feel there is a difference between both the setups here in Pakistan and then in the Malaysian universities and the industry where you were working? Dr. Sana, please, you need to unmute yourself.
Yes, there are a number of differences. I think both places have their plus and minuses. One of the things that you can notice really early on is the importance of having a career is very high in Malaysians, especially among the ethnic Chinese community. It's very important for them to have, whether it's men or women, having a career is a very high priority in their life. I think the situation is a little different here. So that's one of the biggest differences that is easy to notice. In the working environment over there, you can see a lot more, the employees are following the rules and regulations a lot more. Things like punctuality and things like that, they're really emphasized. Having a lot of discipline in these respects is a very high priority. Employers are actually expecting that. So this is something that is very obvious when you compare the two working environments. The other difference here is the different ethnic minorities. There's a difference in terms of the community is very heterogeneous there. Here we have a very homogeneous society in that respect. So there are a number of differences that come with being able to deal with people from different backgrounds, from different cultures, different value systems. So I think both have their benefits. So I think those are some of the things that are very obvious. The other thing is when I look at the student body here, I see a lot of potential. Some of them are very academically ambitious, which is a very good plus point. I can see a lot of potential. I think that we just need to be able to tap it. I think we need to work a little bit more on that. I think these are some of the main points that I can talk about that are very important, very obvious. Thank you.
Now I would like to ask Geeta, you have heard that Dr. Seema is having both the experience of entrepreneurship, research, industry, and then you also have the experience of research and then linking that research to the industry, and you are practically working on R&D projects. So in your opinion, what challenges are faced specifically for females when they are moving towards that side of that side, or moving towards industry or working in abroad? So what do you think, what are the challenges they are faced by the females here?
Thank you, Myra. The thing is, of course, when we are living in Pakistan, the situation is different over there. When we work in industry in Pakistan, it's not very common for the males over there to see females working. But I think it's in Pakistan, the most important thing I observed was the care you get from your society, because males are specifically concerned that females are working here, so they need some space and everything. So these things will be categorized according to the perspective that it's a female. But when you're working abroad, it's not like this. It's like female is considered a colleague, and she's not like she's a female, so she needs to have a separate office or separate thing, or she cannot work, for example, in hardware or something like that. There is no boundaries. Everything is totally open. You can do whatever you like, and you can put in your suggestions. Although I was very lucky that wherever I worked, I had the chance to be at the front and I had the chance to have an exposure towards hardware, and luckily my bosses and everywhere, not only in abroad, also in Pakistan, all my bosses encouraged me toward hardware, and I did a lot of hardware work. The other thing I think the female faces is that like I mentioned before, that we are given a lot of care in Pakistan, but when you go abroad, you have to do everything on your own. Like no one will be coming in the street and asking you, "Oh, can I carry your luggage?" No, that will not happen. You have to do everything yourself. You have to look for an apartment. You have to manage your time. You have to, like, for example, in my case, I'm also doing a PhD online, and I'm also working in my office, but so I don't have like I have to do everything myself. But all these things help you to explore. These things helps you to grow, because basically we do not grow if we do not face challenges. So that's what I have learned from my life, and that's what I will always say to every female in Pakistan, especially because we don't know the outside world. We don't know how it is like, and some of us are scared to go abroad, and some of us are not going abroad because their families are scared that, for example, they'll go abroad and something will happen to them. But I think every female should experience this to see how the world is like, how technology is implemented. This is the most important thing I saw, that like Dr. Simab said, that how her project helped people. This is the most important thing that we need in Pakistan, that we need a collaboration between industry and academia, and we need more females, because with more female contribution, because we know, as you mentioned, Myra, that 52% of the population is female. So it is very important that if this 52%, only 10% in engineers, if more females are encouraged, if female sees how engineering could help themselves in their daily life, in everything, even from switching on the television to anything you do in your daily routine, engineering can help, and engineering can help develop our country. So it is very important for females that they understand there are challenges, but they need to understand that we need to face these challenges to help our own life and to help develop our own country. So I think, of course, it's not easy doing everything, but then again, you explore and you feel more, let's say, content when you have achieved and accomplished all these goals.
Dr. Moira, Ms. Akila just mentioned that there's a difference between the two societies, in our society and when you are going abroad. So here you are more protected. I will rephrase it like this, that here you feel more protected as compared to when you go abroad. So I would like to ask that, since you also have experience of living in China and then coming back to Pakistan, and then you have both the experience of industry and as well as academia. So what do you think are the challenges for the female leaders, especially academicians, they face in their particular fields?
When I was working in industry, the one of the issue that I used to see because I was working in NRTC and NRTC developed a lab for female employees in SEEKs. So they collaborated and they developed a lab only for female employees because their setup of NRTC is basically in Haripur, and they have a big like manufacturing unit there and a testing unit. So somehow it was difficult for ladies to go there every day and also to live in Haripur. So they develop a lab for us there. But one of the thing that I saw in a lot of cases that they used to discourage females, because as everyone know that in our society we have to face this issue that every parent want their girl or to get married at some time and according to the age. So most of the girls that were working with us, they were getting married at that time, but our male colleagues had this idea that if you have to get married and you have these problems of your family problems and some things like that, so you should quit the job. So, and even I was also told at some point in my not in my job when I was studying, so I got this opinion that you should quit your MS, and I honestly speaking, I decided to quit because it was becoming difficult to face these challenges, and also I had a son, and it was being told to me that you should take care of your child and you should not study. But at that time, when I was doing my MS, there used to be HOD in RIMS, that his name was Dr. Munir Tarar. He encouraged me and he supported me. He told me that you can bring your son along with you. And I used to bring my son in RIMS, and everyone at that time knew that she is our MS student and she brings her son along with her. So I think this is the challenge that we females face in when we are working. And also when I talk about China, they have as Sana also mentioned, that they have this concept that everyone should have the career. This is something very important for Chinese, that they don't think anything about anything else. First of all, they think about their careers, be it female or be it a male, and everyone has an equal support system and everyone has an equal opportunity. In China, this is not a concept that okay, you're getting married or you're having a child, so you should quit. So that's not the case there. So even in my during my PhD, I was living there alone, and my son was with my husband, and for some time I also lived there with my 4 months old girl. And I defended my PhD with her. She was also present in my defense. So in China, nobody said anything to me, but in Pakistan, these are the things that females face a lot. If you want to pursue, you should choose your career or you should leave your career if you want to pursue your family life. So continuing both of the things is very scarce. I have seen many females, even my friends from the university, they have left the jobs and they have left their careers to take care of their families and children, and there are many less who are pursuing their careers now. So I think this is the challenge that I faced and many girls face in Pakistan.
So, Dr. Seema, have you ever faced this challenge, and do you think there should be any changes that should be made in our support system for the female?
I would rather say that I have a very good experience in this term because my family is very supportive. My in-laws, my husband, they have supported me all along. I still say that I would not have achieved anything if they have not supported me. So I have 3 boys. The eldest one is 9 years old, and the youngest one he just turned 3. And I have been working since 2010, like just like after my marriage. And my mother-in-law, she used to say that don't spoil yourself. You have done PhD, you should be going out, you should be pursuing your career. Although she is a housewife, but she has a very different vision. She said, I have, because at that time, to do a BA in like early 60s, it was something different. And she was one of those. And she herself is very curious about stuff. She keeps on learning new things. So she motivated me not to leave your career. You should pursue. We will manage somehow. So I started my job. Early days were difficult when my first son was born. She supported me like my own mother would have supported me. She has taken care of all my three kids, and still she is doing the same. She knows that if I'm doing something, it is for the entire family. It is for my kids, it is for them. When I got my award last week, the Best Innovator Award, I gave that award to my mother-in-law and I said, you are equally responsible for this award. I am not the only one who has worked for this award. So, and my husband, yes, he's also very supportive. Because if you have to give time to your research, to your startup, that means you have to compromise on other things. So he has not made any issues out of small things like where is my breakfast or where is my lunch or where is my dinner. And Alhamdulillah, my kids, they are also very supportive. Yes, I do lack at few things, but they see it as my strength that still I am trying to manage. Here I would like to say that I know not everyone is that lucky, especially after marriages, because they have their new family now and they have to make adjustments. And I have so many examples in my life in which that girls have to forgo their career just to make their family or just to have a healthy family relation with their in-laws or with their husband. So I have a totally different experience in this regard. So I think I'm not be able to comment rightly on that. But yes, it is challenging. Physically and emotionally, it's challenging. But if you have the right support system, I think then you can do it.
So do you ever feel guilty that you are leaving behind so many things to gain something else?
Yes, it is. I feel guilty. It's every now and then I feel guilty that, oh, I have not done this. Oh, I have missed this function of my kid and stuff. But on the other hand, I have seen mothers who are housewives, but still they are doing less what I am doing for my kids. So I'm setting up an example for them, I think. I know when I was getting the award, my son was watching the live cast of that event, and my husband made video of him. He was so excited and proud of me that he literally started crying. It was just his emotions that shows that how he takes his mother's career or how he takes me as a role model. So yes, I feel guilty, but I can compensate him, compensate my kids in a better way than I would have been compensating my kids if I was a housewife.
Female need support from both the family and the institute to progress. So, Dr. Sana, can you comment on this? How do you think that a support from family is very important when you are pursuing your career as an engineer?
Yes, I think it's extremely important. I think a lot of the points that Dr. Seema has said are very important. I think that it has to begin at a very young age in your family environment. I think young girls have to be encouraged that to think, to take their intellectual pursuit seriously, to try and slightly remove this idea that they are a decorative item in society. I think they have to find out exactly what it means to be a useful citizen, not only of their own country, but also to contribute to the world. So I think we have to encourage women to think a little bit more on serious matters. I think that for myself personally, I can say that my family has been extremely supportive. And just like Dr. Seema said, my mother's also a housewife, but she has always been encouraging her daughters and her son to pursue higher education. So also support from fathers is extremely important. I've seen a lot of students both here and in Malaysia who had to drop out of their MS or PhD degree because of other commitments and not being able to manage everything. So I think that individual support has to be there. I think that society has to support, institution has to support, and this has to change as a perspective in everybody's mind, that this is something that should be encouraged. The other thing I think is we also have to have a good view of our own personal development as a human being. We should have our own journey where we are learning to grow, and because PhD is such a long duration, we need to understand that a lot of the time we are going to rely on our own initiative, on our ability to motivate ourselves, and sometimes the support system will not be able to help us completely. So we have to have that certain self-belief that has to be there. And I have seen some of the female students, even at the master's level, who are hesitant or they're not sure that they will be able to complete, or this is something that is too challenging. Society in general tends to think that higher education is not something that women take to naturally. So I think some of these perspectives have to change quite a bit before we see a lot more women in higher education.
Sana, don't you think that this perspective is in the overall world, that we have very less female leaders as compared to male leaders? Because what do you think that this is in every society, not only in this country but also all around the world? This support system needs to be improved or enhanced.
Oh yes, of course. This is not something that is just restricted to a particular society. This has different ways in which it comes up in all over the world. You can see that. I know that some of my colleagues there in Malaysia also, some of them were expecting the maternity leave, for example, was not sufficient. So they were also having very difficult time. Daycare was a problem, was not always provided. So this support system and this change of perspective has to happen everywhere. I'm not saying this is just something here. I think this is the degree, of course, differs from in certain societies, but I think that the support system has to be there. Even in an international environment at the school level, I have seen some of the girls are not being encouraged in the way that they should be encouraged. I think that this is not a country or region phenomenon, this is a worldwide phenomenon that has to be tackled. This is particularly true for technical fields. I can clearly say that my area of specialization is information security, and I was a PhD student in this area in the entire university. So this is something that is it's not seen as a field or an area that women are encouraged toward, unfortunately. So yes.
Atila, you have shared a different perspective. So don't you think that, as Dr. Sana is saying, there are strings attached to the females in every society, and there are certain limitations attached to them in every society. Don't you feel it there?
Yes, but here you don't feel it in office, like in work environment. There might be some female issues, female related issues, and for example, also because I'm not married, so so maybe because I did not feel any sort of any other kind of issues, and for me, I didn't feel anything. I have worked in Germany as well, and it's not about male or female over here, at least at workplace. Like nobody ever said to me that you should not do this because you're a female. No one said this. Also in Pakistan, yes, I have experienced there, but here, at least at this stage I haven't experienced such things. Maybe some females do experience a certain kind of hindrance in their work, but so far I haven't experienced any such thing till now. But if you want to, in Pakistan, of course, there is, but I think it's because it has been embedded inside our minds for ages. And now when females are coming out, it is very, let's say, alien for people to see us working like this. But I think with time in Pakistan as well, we will see a change. And I'm very lucky because my family was very supportive, and my parents especially never. I was like Mohira. I was also the first girl, first engineer in my family. Most of my female cousins are married. I'm the only one who is pursuing her career and moving on. It's not like I'm against marriage, but Dr. Simab said that we need a support system, and we need a supportive family and supportive in-laws that are like your parents, and you don't feel. Of course, there are responsibilities and everything, but if support is there, I think a female can do anything, and that's why I cannot comment on this thing that what kind of. I don't have any problem at the moment. It's me, and I'm doing everything for myself. So when I get married and I have a family, then maybe my point of views will be different. So I cannot say any such thing. Also, I did not, in my colleagues also, no one is married. So to understand that if some female has a child, what kind of support system a company could provide, I'm sure that there should be some, what I would comment, that there should be some healthcare, daycare systems in the university, in which so that the females who have kids, they do not feel a difference, and their kids could live near to them. I have observed this kind of environment in Karachi, in Habib University. I saw that there was a really good, like a female after class, they could just straight go to their kids, and they can have like TAs to assist them with their tests and everything. And it was a nice environment because I could see kids playing in the university, and I was like, wow, this is very strange to see so many kids around right outside their office. It's not like you have to go certain kilometers to meet your kids. It was right in the same building that you have a daycare for kids, and then you have your office. And I thought that it was a great idea. Because also people learn from kids as well. I saw one video when they brought a kid inside a class to teach people about empathy, to teach people about feeling, because a kid is innocent and okay, I'm going very off topic. But anyways, my idea, I think that's why I cannot say more about this anyways.
So, despite of all the challenges you think other females may have faced during this whole work and job and home management issues, how do you think still you will motivate the females to work and What is their importance in the field of science?
You asking me or?
Dr. Seema, could you like to comment on it? What's their importance in the field of science?
Okay, so thank you, Myra. So before moving towards this question, I would like to add to the previous conversation that we were having. At job place or at a working environment, yes, I have faced challenges because it's not easy for a male to have a female boss. So that was the biggest challenge I have faced in different roles, like in HOT research role as well, and plus founder of a startup. I have faced these issues. So it's very hard for this male-dominant society to accept that you have a female boss who can give you orders, who can ask you what you have done today, or who can even ask for explanation. So that's difficult for them. I think we need to educate our men as well. We need to inculcate the empathy for the girls, for respect for the girls, and we need to make sure that they understand that girls are equally important in the society and they can make change. So moving towards your next question, so I would really, in my even classes, when I'm teaching undergrad, master's or PhD students, I really encourage them, female specifically, to come forward. But I have observed that females have a very specific sense, which males does not have. You have a sense through which you can see the problem from different perspectives. And plus, if you are seeing a problem from different perspectives, that means you are able to reach at the solution from different perspectives. So if you have that ability in your team, if you have a female who can see different perspectives of a problem, that means you can reach a better solution. So this is one thing I have noticed. There are many female students of mine who have the same issues. They wanted to do their PhD, but their parents are not allowing them, that you have to get married and stuff like that. So I remember one of my students, she called her mother and she said, okay, talk to my teacher. And I asked her, kindly let her go for the PhD. She got admission abroad and stuff. And her mother said, no, she needs to get married. She's getting old. How old she is? She is just 25, 26 or 28 maybe. She's not getting old. So no, she needs to get married. Okay, do you have any option for right now for her wedding or for her marriage, or do you have any proposal? No, we are looking. Okay, then why you are stopping her? If you don't have any option right now, let her go do her PhD. So what's the probability that if she does not go for the PhD, she will get married tomorrow? He said, no, I cannot guarantee that. And then let her go to do her PhD. So yes, you need to motivate the students, girls, as well as their parents. So I think being a female in that role as an instructor, so I have played motherly roles as well, and as a advisor role as well. So it's very important to keep them motivated, because females, I think they are very emotional, and emotional in a sense that we take everything very seriously, whether it's our job, whether it's our career, whether it's our family. We are emotionally attached to everything. So if someone says, okay, you cannot do this thing or you cannot pursue this thing, we get very emotional to it, and we start thinking in that direction. Maybe I'm not that strong, maybe I'm not that good. So there should be someone specifically in a female role to whom they can look up to. So yes, it's important, and I think the female faculty or the female instructors, they have a huge role in society, not only for teaching these young minds, but also keep them motivating to do good in life.
And Dr. Seema, I would like to second you here, because we female are very much emotionally attached to our work as well.
Yes.
With female members in your team also improves the quality of your work, because we are not only doing it just for the sake of doing it. We are actually putting our most of the effort, most of our time in order to achieve something out of it, and then we get emotionally attached to it as well. So you are playing different roles, diverse roles, as a mother, as an entrepreneur, as a researcher. So how you are going to motivate our female researchers to come towards entrepreneurship, to commercial, once they should do the PhD and then they should come towards entrepreneurship? How would you encourage our females in this?
Okay, so I would work on the same lines. The motivation from, so I got my motivation from this very small thing, and it was because that I was feeling that my research is not worth anything if I'm not helping anyone. So if you feel like if your research can help even a one person, deserving person in the society, you will see a difference in in yourself as well. When you think that you are helping the society, when you think you are getting the feedback that this thing of yours has helped me in this particular thing, even if we take it as a teacher, if your graduated students meet you after 4 years and he said, madam, you scolded me at that particular time and it has helped me to do this thing in life, you feel so satisfied. Yeah, so the same thing I would like to say to the PhD students, to the master students, even to the undergrad students. It's not necessary to do your PhD and then only you can do entrepreneurship. It's just the motivation in you, how you can come up with an idea, how you want to make a business out of it. If you are doing some research and you think your research can help society, you can go for its commercial end. You need to identify what can be the commercial product of your research. Okay, so every research can be part of a commercial product, but you have to build around it. Okay, so your raw research cannot be used as a as a commercial project or a product, because we have proven our research in theoretical terms. We have not evaluated our research in terms of its practical usage. So yes, we have to build around it, but it's very satisfying when you see your product being utilized by different sectors, by different people in the entire community or whatever you are doing.
Thank you, Dr. Seema. Talking about the satisfaction you feel following your career path, Dr. Mohera, despite the challenges, how would you motivate our females to pursue their career, and what encouragement would you like to give to them?
I would like to say that despite everything, despite what our society thinks, we females should be financially independent. That's what I feel. That if you're financially independent, many things change and many people also change. So, so this is the one factor that due to which people in our country, they get educated. But apart from this, I think if you're doing something for your own satisfaction, that is, if you're doing PhD, just do it for your own satisfaction, to do something in life. So if you feel like that, then do PhD. And if you feel like to pursue your career, and if you think that it gives you satisfaction, then obviously pursue that. If you don't think that education is your side, then go do something which is of your interest, but at least get educated, because education is very important. It changes you, it changes your mind, it changes the way that you think about many things. I feel if I talk about myself or my family, I will tell you that I have 3 sister-in-laws and all of them are PhD. My husband is PhD. My younger sister is also PhD. So apart from PhD, this degree, I feel a difference in their thoughts, which I haven't seen in many other families. They think about things very differently. There are no gossiping sessions in our home. We usually talk about, more important stuff in word and life. We have very educated discussions. So things like these. I don't think anyone talking about useless things. So your perception of life changes. So I would say to all females, and I say this to all, even my younger sisters and all my students, that whatever you do, just finish your education. Even if you get married, even if you get children, complete your education. I have completed my master's after my son, and I have done my PhD after my kids. So it is difficult. Many people will stop you or maybe say that you shouldn't do, but do get motivation from something, and you will see that even your children will be proud of you. As Dr. Sima mentioned, that when she was getting the award, her son was very emotional. Same happened to me when I defended my PhD. I was in China and my family was here in Pakistan, and they were attending my defense on video call, and I could see that all of them had tears in their eyes because the 4 years of my PhD were difficult for my whole family. So you will get results at the end, inshallah. So don't leave your education and don't think that you cannot do anything. Everyone has some quality, everyone has some potential. So just get to know about your potential and follow your dreams. Don't leave yourself for doing some other things. Everything will happen at its own time. Just I will say that every girl should follow her dream. So that's I think important to remember for the females. I have a question from Dr. Sima. Sorry, I wanted to ask, when we are designing an RF product, there are very many challenges, like of course the fabrication, the product launching and everything. I mean, RF is a very expensive field, I suppose the most expensive of all. So what are the, like, how can one cater such challenges? I mean,
Okay, so my product is artificial intelligence based project. So it's a software. So I don't have any hardware related problems, but yes, I need a very specialized resource for that, for development of that. And for that, I acquire funding from HEC under Technology Development Fund Program.
Okay. Thank you.
Can you also please share some other opportunities like this which we can tap to get funding for the projects which involve expensive hardware?
So HEC fundings, they are they give in diverse fields. So if you go for HEC, they have funding for hardware plus for HR. But they have certain amount that your hardware cost should not go beyond 30% of the whole cost of the project. So HEC have different programs on that. Plus Ignite is another funding agency who gives funding for research projects, and for even now they are giving funding for startups as well. Then we can have PSF, we have Punjab Development Fund Program. So there are many funding details, and NUST-RIMMS is very active in that. They keep on sending funding opportunities every week, I guess. So I think I am flooding my faculty's emails from those emails. So yeah, we have a lot of funding opportunities, national and international.
Now, I would also like to ask Dr. Sana to share her motivational speech with our female fellows. That how do you motivate them to still work in this field and to pursue their career?
Okay, there are a number of things. I think I can start by sharing my own personal experience. I think for me, after I did my bachelor's, I've pretty much figured out that I wanted to work in security. It's usually not an area that's encouraged for women, but it was my interest, and I can clearly say that despite all the difficulties, research-based difficulties I faced in my MS and my PhD, at the end of the day, it was the fact that my interest in the field was what carried me through. I just did not give up. And the other thing that I think contributed was my family support. I think my parents were extremely, they have a huge role to play in this respect. I think for that, there are few things that can get in the way when you are the passion or the motivation lies inside of you. That's number one. Number two, I think that women need to understand a little bit about, okay, for my field, I can also say information security. They need to understand the importance of information. Information is power, and education is power. It is going to be the power to change you, your family, your society, your culture, and entirely the world. I can see there's some questions also by this one or two individuals about the issue of domestic violence, for example. And this is the reason why I'm also trying to highlight the importance of education, not only for women, but also for men. And I do not think, this is something I've also noticed here and in a number of other places, once people finish their, whether it's their bachelor's or their degree, they said, okay, I'm done with education. No, you're not done. You are never done with education and learning. This is something that we have to change in our mind. Those of you who come from a religious background should know this very well. You are encouraged to learn throughout your life to improve yourself, and this is the only way in which you're going to create a better society. Our mindsets have to change, and if you are interested, and I think women are interested in contributing and helping people out, and I think that Dr. Simab got her motivation from the contribution that she was making to society, to actual people. I think a lot of women have that motivation inside them. They would like to improve the conditions of those people who are, let's say, less advantageous situations. All right, so I think that the other point that was made about financial independence, I think is extremely important as well. But again, I would say it is secondary, but it is extremely important for a woman to be empowered through her own financial resources. So I think that that's a huge factor. Okay. Intellectual satisfaction, again, this is again something that has to change, a perspective that women have to change about themselves. What satisfaction they can get, both from just pursuing something that is entirely intellectual and from pursuing something that is actually having visible outcomes. A lot of the times when you see there is a bias, not only here, but I'm talking about internationally also, that tasks that require a lot of detail, depth, focus, dedication are not usually seen as something women usually do. They're usually seen as a more emotional creatures that are less likely to pursue intellectual or theoretical fields, and I think this is something that also needs to be changed a little bit. I think women are capable of doing both and should be encouraged to do so as well. I think that's basically it. I think the most important thing for women to realize is that education should not end. That's all.
There are some questions in our chat to ask. One of the question is, what is the motivation for women behind PhD alongside family commitments? This has been, I think, answered well in the talk overall. So Akila, can you answer this question, that what's the importance of women in this field? Just a quick answer.
Like I mentioned before, you mean the RF field, right? Engineering field.
In the field of science. Like
yes, of course. That's what I mentioned before, that that 52% of the population is females. So of course, if female contributed equally in this field, our country will develop. Like also Dr. Sana mentioned that our country will it will eventually affect the whole world. Like it is so important for the education, and science is so important. And of course, when more than half of the population is female, then you could imagine if females start contributing, how much it will enhance our development. So I think it's very important that a female should be a part of this, and not to compete with men but to be like an individual soul, because both male and female, like Dr. Simab said, have their own perspective. Like they have their own perspective to see a thing. So if both male and female are working together, they can come up with good solutions to many problems. And I think this will help a lot in the development.
Thank you, Akila. Now here I would like to conclude this session. I would like to thank all of my worthy panelists for sharing their experience. The experience you all have shared with us today was very motivating, and hopefully this session will be a source of encouragement and inspiration for all the young females who are pursuing their career in the field of engineering, in the field of science. I hope this session will help many women to strive for better and to believe that nothing is impossible in life. I would end this session with a quote from Marie Curie. We must have perseverance and above all, confidence in ourselves. Thank you all for joining us today. And I hope this session will be a source of encouragement for all the females who have listened to us today, and all the others will also get benefit from it. Thank you.
Thank you, Myra.
Thank you.
Thank you so much, Myra, for giving this opportunity and meeting other accomplished ladies. And I hope that we continue to meet up sometime again. And Dr. Simab, I hope there are more females like you, and we would become like you, so that Pakistan will become a better place, inshallah.
Yeah.
That
And
means
yeah.
Yeah, that really means a lot, and now I'm feeling more responsible.
Yeah. And I also want to add one last thing, that I've started a Facebook group, Women in Microwaves, and I would like all the females to come under one platform, and so that we can help each other out. There are many females over there already, but it would be nice if more could join us.
Okay, thank you very much. I would like to thank all the panelists for joining our seminar and sharing your thoughts. I'm sure they will be very encouraging for female students and faculty members as well to excel in this area. So now I think it's time to conclude, and I hope to see you again in some other seminars as well. And till then, have a nice day. And then now I will move to our next speaker to start the talk. The next talk will start at 17:30 hours. Thank you very much.
Thank you.
Thank you. Allah Hafiz.
Allah Hafiz.
Thank you.
Hello.
Hello, Professor Rabia. Thank you very much for joining us, and I'm sorry for the inconvenience due to the password.
No worries, no worries. I'm glad that worked out. Can you hear me okay?
Yes, I can see you and hear you very clearly, and I think without any further delay, we can start the talk. So first I will introduce you, and then you will share your screen, and we'll start your talk.
Sure.
Okay, thank you. Welcome back. Our next speaker is Dr. Rabia. Dr. Rabia received his MS degree in Electrical and Electronics Engineering from EPFL, Switzerland. Her master thesis was advised by Professor Christian under Platform Circuit Technology underlying Heterogeneous Nano and Terra Systems program. Dr. Rabia obtained her bachelor's degree in Electronics Engineering from Sabancı University, Istanbul. Dr. Rabia was a postdoctoral research associate in the EECS department of MIT, working with Professor Ananath Chandrakasan from March 2016 to August 2018. Dr. Rabia received her PhD degree in electrical engineering from Columbia University, NYC in 2016 under Professor Peter Knight and co-advisor Professor John Wright. Dr. Rabia is currently an assistant professor of electrical and computer engineering department at Boston University since August 2018. She is the leading the wireless integrated system and extreme circuits laboratory. She was a member of analog and RFIC design research group housed in the Columbia Integrated System Laboratory. She is the recipient of several national and international honors and awards. So without any further delay, I request Professor Rabia to please proceed ahead with her presentation and share his screen. Thank you. Over to you, Professor Rabia.
Thank you. Thank you for the kind introduction and invitation. Let me share my screen. Okay. Can you see my screen, Charlie?
Yes, I can see your screen, but the slides are not in the full screen mode.
Let me try that. Can you see it now? Or?
It's perfect now. Yeah.
Oh, great. Okay. So let's get started then. Thank you for waiting until the end of the day, and due to the time difference, and it's a pleasure to talking to all of you. Hopefully we'll get to meet one day in person as well. Today we're going to discuss some of the research work we do in the 5G and related to the future of wireless communications. And specifically, we are going to focus on two of my key contributions in this domain. One of them is to enable the on the left side, you're seeing the secure wireless communications work, and on the right side, we are going to discuss how to handle the wireless data traffic growth while achieving spectrum-aware wireless communications. For some reason, unfortunately, my cursor is not detecting this warning, so I'm going to refer to it as left and right. I'm sorry about that. I'm not sure what's wrong with my laptop today, but hopefully we can get through the talk without any interruption. So in my group, we are focusing on two of these key domains. One of them is secure wireless communications. The other one is how do you achieve spectrum awareness and spectrum efficiency in wireless communications. And these are actually based on my postdoc and PhD work. So we continue to explore new opportunities in this space, but also we have been broadening into new application domains. My group's research approach is to develop tightly coupled system solutions that are at the intersection of analog and RF circuits, combined with security, signal processing, wireless communications, recently biosensing, and even information theory. And what's unique about these solutions is they really take advantage of the application, so they're very application specific, and we do cross-layer optimization of these fundamental subjects together for better energy efficiency and higher performance. So you see some of these example application domains that we work in my group. On the top left side, we have been collaborating with Professor Runan Han and Professor Ananta Chandrakasan at MIT on secure packageless terahertz identification tags, which we're gonna briefly discuss towards the end. On the top right side, you see our Grand Universal Decoder project. This is intended to be used for 5G systems with ultra-low latency and low power. And we are also working in the bio domain, so we have several works that's focusing on ingestible devices and embedded drug delivery systems and their security. So we have a wide range of applications we work on, and as I mentioned earlier, we worked at the system level, even though our core background is in circuits. Today we're going to discuss Secure Wireless Communications project, and this was done at MIT in collaboration with most of my collaborators that you see on the screen, and some of them are currently now in industry. They used to be postdocs as well at MIT. So to get started, let me motivate the problem. So if you think about it, security is one of the critical requirements for the wide deployment of IoT devices. And the particularly challenging attack scenario, wireless attack scenario, is selective jamming. What is a real-world example of a selective attack? Marriott Hotels in US was fined $600,000 by FCC because they were actually blocking their guests, consumers' Wi-Fi networks a couple years ago. So at the same time, they were also charging their customers for the hotel's own Wi-Fi network. And this attack scenario is known as a selective attack, even though it's not a wireless attack in this case, not at the physical layer as we are looking at. The reason it's a selective attack because it was specifically targeting the customers in the hotel. So they were only blocking those consumers' Wi-Fi networks. So what is a physical layer attack as a selective jammer? Selective jammer has a single victim that it's targeted while the other devices experience no interruption in their service. So in contrast to one of our very well-known jamming definitions, broadband jamming, this selective attack allows the attacker to maintain deniability. So you cannot distinguish this attack from packet loss experienced over a poor wireless data link. We demonstrated a selective jamming attack against commercial Bluetooth low energy devices, and that's actually what you're seeing on the screen. On the left side, you're seeing our demo setup, and on the right side, you see the packets received by a commercial cell phone, commercial receiver. And here we are targeting the BLE fitness device with our selective jammer that we built, while the headphones continue their communication with no interruption in service. And you can see that the packets from the BLE fitness device have CRC errors, so they're selectively jammed, versus the BLE headphones at the same time have no CRC errors, so they continue their communication seamlessly with no interruption. Of course, this attack can be a serious attack if we were targeting BLE-enabled medical devices, not headphones and a fitness device, but this was just a demonstration without harming anyone to show the potential of the attack. And the two reasons why the BLE is vulnerable to these physical layer attacks is that it's slow hop period and the individual bit location predictability. And today we are going to discuss how to address these vulnerabilities over a system level approach. So we use this system level approach with cross-layer optimization in most of our work, and that's also what we applied here to achieve secure wireless communications. And on the screen, you see the proposed physical layer security platform that utilizes on the bottom side the frequency agility of MEMS devices. So it starts from devices in combination with novel RF architectures and protocols. So it is across different layers of the stack. And today we're going to discuss how this scheme provides physical layer security by utilizing all of these layers together. Let's start by discussing the security vulnerabilities of current wireless communication schemes in detail and how to enable cross-layer security. So we are going to address 5 challenges across different layers of the stack. And the first challenge is the slow hop period. What do I mean by that? If you look at the Bluetooth low energy communication schemes, the vulnerability comes from the fact that BLE employs packet level frequency hopping. On the screen, you see the frequency versus time graph, and each data packet is sent on a single 1 MHz frequency channel. By staying there for 612 microseconds, so they have a relatively slow hold period. However, an attacker only needs 1 microsecond to localize the channel, which is inversely proportional to the channel bandwidth of 1 megahertz. And then they have all of the time after that 1 microsecond to jam the remainder of the packet if they were targeting only selectively one of those victims. So what's our proposed solution? To provide resilience to this attack, we propose physical layer security through an ultra-fast bit-level frequency hopping scheme as shown on the slide. And in this scheme, what you are seeing is every bit is sent on a unique channel by hopping at the 1 microsecond bit period. So we are sending every bit on a random channel, and we are changing these channels every 1 microseconds. And this fast hopping rate prevents the jammers from accurately detecting the target transmitter's carrier frequency and initiating interference before the target's next hop. So the transmitter spends the minimum amount of time at 1 frequency channel that is needed for the target receiver to decode. And you might wonder why it is hard to achieve this 1 microseconds. If you think about IoT devices, most of them are very resource constrained, low power devices. And if you wanted to do this with conventional hardware with low power, they typically change their frequencies slowly. And one of the common ways to, for example, synthesize frequencies in RF is to use the conventional phase-lock loop structure with a crystal oscillator, let's say at 20 megahertz. But unfortunately, they change their frequencies slowly at low power implementations. Here, actually, on the bottom part of the slide, what you are seeing is the startup power on the y-axis versus startup time on the x-axis. And this is showing for crystal oscillators and the PLLs. Most of them are state-of-the-art PLLs and crystals separately. Actually, it's not the combined version, but what you are seeing is the startup time is in the order of tens to thousands of a microsecond. But what we need is a device that can start up faster and change frequencies faster in the 1 microsecond level. So to achieve this, what we are doing is we are utilizing bulk acoustic wave resonators for their frequency agility. On the left side, you are seeing the bus structure. It's a piezoelectric film sandwiched between 2 electrodes, and the acoustic wave bounces from top to bottom surface to form a standing acoustic wave. And of course, what's known with the bar resonators is they have a quality factor that's similar to crystal oscillators, but they can actually resonate at higher center frequencies. And the startup time of a resonator is proportional to the quality factor, but inversely proportional to the resonance frequency, which makes them faster compared to the crystal oscillators. So what we are going to do is we are going to remove the PLL phase-lock loop with the long settling time due to their settling time through the loop. And we are going to replace the crystal with a BA structure, bulk acoustic wave resonator. And we are going to actually build this bottom transmitter structure that you see to make it a frequency agile and a fast startup transmitter. Of course, nothing comes for free. So the challenge of these structures, bar resonators, even though they provide better startup and frequency agility performance, they come at the cost of limited tuning range. For example, you wanted to cover the ISM band with an 80 megahertz of wireless spectrum available at 2.4 gigahertz. But if you use a typical bus structure, it's not sufficient to cover that 80 megahertz. As you can see on the right side of the slide, they only have 4 to 5 megahertz of tuning range. So you cannot use a single BA device and cover an 80 megahertz of bandwidth as long as you don't play tricks on the circuit side. So you cannot just use the device itself and expect to have that full coverage. You have to use around 16 BA resonators, of course, which is not practical at all and extremely bulky. there was some prior work which used a couple of bar devices, but they were only able to cover a small tuning range. So in this work, what we have done is we use a single bulk acoustic wave device, and we synthesize frequencies from the single bar device to cover the entire 80 megahertz of band. So let me walk you through the structure. So you see the hardware structure, and you're going to see the waveforms along the way across the structure. So the first waveform you're seeing on the top is we are starting with the bar device itself, the output of that bar resonator, and it's resonating at RF frequencies, let's say the F bar, and that could be the middle of the center frequency of the ISM band, which is, let's say, 2.44 gigahertz. And then we divide down this high frequency to low frequencies by using a programmable integer n divider to generate the baseband frequency that you are seeing on the bottom right side. And what we do is we take this low frequency and the high frequency and we mix them. So when we mix, this allows us to synthesize a new frequency that's shifted by the amount of the baseband low frequency component. As you see now, the center frequency is that bar frequency plus the baseband frequency, and you still have that small tuning range. So what do we do with this structure? Let me give you a numerical example to start with. So let's say that my bar resonator, as you are seeing on the top graph, it's at the black one at 2.44 gigahertz. I divide it down by an integer n programmable divider frequency, and it divides it down to 3.8 megahertz. And I mix that component back with the 2.44, and you see the output of that at 2.4438 gigahertz. Now the delta F between those two carrier frequencies is 3.8 megahertz. And as you might have noticed, that's smaller than the tuning range of those bar resonators. So you can actually cover the entire tuning between them by using the bar tuning itself. So now how do we extend this to 80 megahertz? You can change the divider ratio. You can change the divider n ratio, and you can cover the entire ISM band with a single bar device. So you can step through the divider, and you can use the bar tuning range to hit the channels between those divider steps. And to demonstrate this, we build a custom chip with a full ISM band coverage of 80 megahertz that uses a single bar resonator that has a fast startup time of 2.3 microseconds. This was implemented in 65 nanometer CMOS and consumes 6.4 milliwatt of power from a 1.1 volt supply with an output power of 0 dBm. On the right, you are seeing the measurement results, and especially the measured frequency coverage. On the top curve, the A curve, what you are seeing is there are some gray carriers. Actually, there are a couple of them, 3 of them on the screen, that are generated through the divider steps using the programmable n divider. And you are also seeing some blue carriers that are coming from the bar oscillator tuning to cover every 1 megahertz channel in the 80 megahertz of bandwidth. And of course, what's important is, which we haven't discussed yet, there's a need for a filter in the scheme, a low pass filter. Let me actually just come back here. Let me show you why we need that low pass filter. So as you notice, when you divide it down to baseband frequencies, there's a need for a low pass filter because there are some in-band spurs. There are the third and the other harmonics. When you mix it up, it will still be in the 80 megahertz of bandwidth. So we want to lower them as much as possible. And that's what you're seeing in the B plot. When we zoom out, you're seeing some of those spurs in the 80 megahertz of bandwidth. But what's the goal is you want to keep those in-band spurs below the Bluetooth low energy protocols spur threshold of minus 30 dBm with a 0 dBm output power. So most of those spurs are below the BLE emission limit. Okay, so when we implement this, did we solve the problem that we have? Yes, we did solve the limited tuning range problem, but unfortunately we haven't achieved our goal of 1 microsecond hopping yet. because the challenge is now coming from the settling time of these baseband circuits. And there's a dead zone associated with these circuits that basically doesn't achieve the 1 microsecond hopping goal that we have. So if you look at this hardware diagram, we had the bar frequency on the left side, right? And then we divide it down and we mix it back up to the other frequencies. So this bottom part of the pad, which has the low pass filters, has a settling time associated with the system, which creates dead zones between the hops. So to avoid this, we introduce time interleaving. So this is like a ping pong structure. We have 2 transmitter pads and we achieve this desired speed of 1 microsecond at 1 megabit per second data rate by using this time interleaving methods. And if we look at the full structure, it is actually looks like this, the full system. We have 2 separate pads and both of them has individual bar devices on the top pad and the bottom pad. And they are both able to cover the 80 megahertz of bandwidth. And time interleaving these 2 pads allows us to actually continue the channel selection on the inactive pad, while the concurrent bit transmission on the active pad to maintain a 1 microsecond of hop period. So here you're seeing that we switch the active and the inactive pad. So we continue to select the new channel selection on the inactive pad while we continue to transmit on the active pad. So this is the full structure, and this was also implemented on in 65 nanometer CMOS, and it can achieve this 1 microsecond bit level hops. So if you look at the measured spectrogram, what you are seeing here is that the system can hop from one end of the ISM band from 2.4 gigahertz to 2.48 gigahertz in 1 microsecond with no dead zone. But so far, we only address one of the BLE vulnerabilities, which is the slow hop period. Now we are going to address the second challenge, which is the individual bit location predictability. This is our last challenge to address in this space. So the bit location is leaked. And what do we mean by that? Traditionally, Bluetooth Low Energy typically uses Gaussian frequency shift keying modulation with a fixed carrier offset of plus minus 250 kilohertz for bit 1 and bit 0. And this creates a problem because it's a fixed carrier offset. As soon as the attacker localizes the carrier frequency, they can selectively override individual packets, individual data bits, not even packets, sorry, let me correct myself. They can selectively override individual bits in a packet. So the attacker can gain complete control over the packet that will be received by the victim. That's what they are seeing here. So since the attacker knows that it's a fixed carrier offset, it can basically change and take control of the packet. So how do we protect against the scheme, this attack, as we develop the cryptographically secure, data-driven, dynamic channel selection that enables 80-way pseudo-random FSK modulation. First, I'm going to show you the target receiver view, and then I will also show you the attacker view. So if we look at the target receiver and the target transmitter communication, not from the attacker's perspective, we envision that the transmitter communicates with a wideband base station receiver, which calculates the hopping sequence of the transmitter based on the pre-shared secret key. Receiver captures the entire 80 megahertz of bandwidth by using Nyquist rate ADC type of structure. And the bit decision, it's a non-coherent detector, so the bit decision is based on channel energy comparison for current bit 1 and bit 0 locations. In this example you are seeing on the slide, transmitter designates 2 channels for bit 0 and bit 1. For bit 0 it's channel 4, for bit 1 it's channel 31. And this is a random channel selection, so the next bit it will be a different set of 2 channels that are assigned to bit 1 and bit 0. But the target receiver knows which channels to compare in terms of the energy, because the reason is it has the pressure secret key. So it looks at these 2 channels, and depends on the energy, it decides if it's a bit 1 or a bit 0. So if you look at the attacker's view, what happens? Even if you provide a full history of transmitted hops to the attacker, they are not able to predict the location of any future bit. It doesn't matter if they know the current hop, they cannot figure out what's going to be the next hop. And the best strategy for an attacker to do is random guessing, and that makes the selective override of individual packet data bits infeasible. This scheme, as it might sound surprising, it also provides data encryption in the physical layer. Why is that? So let's say that you can, as the attacker, on the bottom view that you're seeing with the red part, that let's say that you are able to detect that there's some energy in one of the channels, let's say channel 31, but you don't know if it's a bit 1 or a bit 0, right? I mean, both of them, even if you are sending a bit 0, you are going to have energy in one of the channels. So it doesn't know if it's a bit 1 or a bit 0 without obtaining the secret key. So this provides additional data encryption in the physical layer. And this structure was actually built together with that BAW-based transmitter, even though I didn't show you this part earlier. So on the top now you're seeing this digital block, which is actually a cryptographically secure generator. So we are using a Keccak-based pseudo-random number generator, which is taking, on the top left side, you're seeing a data FIFO. So as soon as the data bits comes in, it maps them based on the data, current data bits, so it's data driven, to random channels, and it controls how the switching between the time interleaved paths should happen and which should be the next hop frequency. So this was actually part of that second chip that I just showed you. And if we look at the measurement result here, I want to give you one example. So here again, you're seeing the measured spectrogram from the chip. On the right side, the top part, what you're seeing is the data packet that we want to send. It's composed of, let's say, 5 preamble bits, 5 bit ones, and then there's some example of data bits. And underneath of that data bits, what you're seeing is the bit 0 and the bit 1 locations. In every hop, we select 2 random locations, one for bit 0, one for bit 1. And depending on the current data bit, we select which the transmitter should hop to. So here you're seeing that in the first bit, it's a bit 1. So we are going to select channel 14. So it starts on the spectrogram on the left side of the spectrogram on the bottom plot. You're seeing that it hops to 2.414 gigahertz. And the next hop depends on the new set of channel frequencies. So we are at each microsecond, we are selecting the channel randomly based on the user data bit stream by using this on-chip cryptographically secure random number generator. And we are using the time interleaved BAW-based transmitter to hop to the selected unpredictable carrier frequency. So to summarize the contributions from this work, we demonstrated the first integrated bit level frequency hopping, not packet level, that hops at 1 microsecond period, which allows us to achieve 600 times faster hop period than packet level frequency hopping, since we moved to a bit level scheme for security, but it also provides unpredictable hopping sequence and unpredictable bit location. So now we are going to actually switch gears and start discussing the spectrum-aware wireless communications for the other half of the talk. But if you have any questions about this work, I'd be also happy to address it now, or if you want to do that at the end, that's also fine with me.
Dr. We can have the question and answer session at the end of your presentation.
Okay. Are you still able to see the slides properly as full screen?
Yeah, they're visible.
Okay. I had a problem with my screen for some reason today. Sometimes it doesn't show, but I just want to make sure. Please let me know if you have any issues with the slides. Okay, so that was the first half of the talk, which focuses on one of the important challenges of low-power IoT devices. And we actually have a recent paper, which is a survey paper that was published at IEEE SSCS Solid-State Circuit Society magazine in the fall issue, focusing on this type of low-power security solutions to address actually some of the challenges of wireless communications. Now I'm going to switch to my PhD work that's addressing the wireless data traffic. And this work was done at Columbia University, and of course, I would like to acknowledge my collaborators on this work. Here, again, it's a wireless problem, but a slightly different problem, and actually they complement each other, right? So security is one side of the question to do with the low-power devices, but also with this growth of these connected nodes with more content, there's also an increase in the wireless data traffic in the near future, and it's expected to be in the orders of 1,000-fold. So this data storm creates something called spectrum scarcity. Some of you might be familiar. And why that's a problem, we have to utilize the spectrum better. So why that problem comes in the current wireless communication systems, the challenge is that currently in today's wireless communication systems, particular frequency bands are assigned to specific users for once and forever. But there is an urgent need for shared spectrum access technologies that actually you're seeing on the screen to replace this outdated, highly inefficient and fixed spectrum solutions. To overcome this spectrum shortage, most of these future wireless communications are envisioned to employ mobile terminals that can assess the usage of the spectrum and dynamically access the available spectrum. Here you're seeing that let's say that our communication system is changing the frequency band rapidly. And you have to be aware of the spectrum environment to locate and avoid the interferers, strong components in the spectrum, and also to locate and avoid weak incumbents, weak signals, so that you actually fairly coexist with other devices. So you're going to opportunistically access the spectrum, as you can see in the hopping scheme, to be able to use the spectrum efficiently. So I want to give you two example scenarios that are actually related to some of the current deployment scenarios. The first one is the LTE license assisted access as one of the use cases of this dynamic shared spectrum access scenarios. Here on the left side, you see the scheme where we have multiple devices, and time division duplex LTE terminal forms an anchor link in a license band. You see the primary links hopefully on the slide. Unfortunately, I'm not able to point them anymore, but there are also opportunistic additional links in the unlicensed bands, let's say at 5 gigahertz with a 500 megahertz span and 20 megahertz resolution bandwidth. An important feature of these LTE license-assisted access systems is to ensure fair coexistence with Wi-Fi terminals. And they employ this listen before talk mechanism. So LTE terminals perform energy detection based clear channel assessment to opportunistically transmit on the unused channels of the spectrum in the unlicensed band. So they have a possible channel access mechanism that was envisioned, which has a two-step sensing process. The first step is to rapidly detect the location of interferers, strong components over a wide bandwidth within that unlicensed band, let's say at 5 gigahertz band, to construct a channel exclusion list. And then you perform clear channel assessment for a specific minimum amount of time, let's say 9 microseconds, actually that was one of the target numbers, on a set of candidate channels outside of that exclusion list that you created by detecting the interferers to check for weak Wi-Fi incumbents. And why these durations are important, why they are so in the microsecond level, if you think about it, the TDD subframe duration is assumed to be in the order of 300 microseconds to enable the fast link direction switching in order to achieve the latency, round-trip latency goal of 5G, which is 1 millisecond. So it's assumed that you only have 25 microsecond total for this two-step sensing. And if you want to do, let's say, twice this clear channel assessment, you only have around 7 microseconds for the wideband interferer detection. So it's a very short time to capture across a frequency span of 500 megahertz or a gigahertz or even larger frequencies, all of those interferers in a dynamically changing spectrum environment. Another deployment scenario is actually the PCAS band, which is a 2.7 to 3.7 gigahertz. This is recommended for feature systems in the United States with improved spectrum utilization efficiency by sharing that gigahertz of federal government spectrum with non-governmental entities. And they have a similar mechanism to fairly and friendly coexist with lower tier devices. Lower tier devices need rapid sensing based on to allocate their spectrum usage and to figure out which spectrum to use, which spectrum band to use. So today we're going to look at how do we detect these interferers over a wideband spectrum. And we're going to do this again with a system level approach, but this time it's a little bit different approach. So this is more signal processing heavy to achieve time and energy efficiency. So we are going to start with our spectrum model that we assume. And if we look at the spectrum, let's say we are going to use the example, the second example, 2.7 to 3.7 gigahertz. We are going to capture a 1 gigahertz of bandwidth with a 20 megahertz resolution bandwidth. What does it mean? Is you have 50 bins to capture. And let's say that there are some signals that you're seeing, but there are only 2 green signals, which are the interferers that are above the threshold. And the rest of them are below the threshold. Those are the weak incumbents. So with what does this figure shows us is with thresholding, you can make the spectrum sparse. There are only 2 signals out of 50 bands. But what's interesting is this is a dynamic spectrum. So you're seeing different time snapshots of the spectrum in different times. And spectrum is dynamic, so it means that signals could move around. They could be anywhere in those 50 bins, but we have to capture them quickly. So we want to take a 1D spectrum image. And going forward, actually, I'm going to use this bottom figure that you're seeing. What is that showing us? That's actually just the green parts are showing the location of those interferers, but they could be anywhere in those 50 bins, so we have to figure out where they are. And in the example we are going to use for the rest of the talk is there are 3 interferers we want to locate. It's sparse, so there are only a couple of them, so we're going to assume 3 out of 50, but they could be anywhere in those 50 bins. So how does the traditional spectrum analysis work? If we look at traditional spectrum analysis, on the left side, you're going to see the most familiar architecture to all of us, which is the spectrum analyzers, the analog spectrum analyzers that we had in our labs. So here you have a single branch sweeping spectrum scanner. And each pin is scanned sequentially by sweeping the load, driving the IQ down converter. So you go through bin by bin. Of course, this has low power and less hardware complexity, but it has a very long scan time, which is proportional to the number of pins that you want to capture. So there is a risk of missing the changes in the dynamic spectrum. As an alternative to this, you can go and build multi-branch spectrum sensor with multiple branches. And on the extreme side, you could go build 50 parallel branches, 1 for each bin, to instantaneously capture a gigahertz of spectrum. This approach is fast, but it's power hungry and impractical in terms of hardware complexity. Also, you can capture this wideband spectrum with a Nyquist rate wideband ADC, but at the end, what is the trade-off? So if you look at it in all these solutions, even though you reduce the scan time by using multiple branches or a wideband nyquist rate ADC, you increase the power consumption and hardware complexity when you move to higher frequencies as well as wider bandwidths. So there is always a fixed trade-off between scan time and power in traditional spectrum sensing techniques. So the energy consumption stays constant to a first order for all of these approaches. We demonstrated the use of sparse signal processing, it's also known as compressed sensing, to overcome the fixed trade-off in time, scan time, hardware complexity, and energy efficiency that is found in the traditional spectrum analysis methods. So let me give you a brief overview of what is sparse signal processing theory, how does it work, and then we will look at the hardware side. So I'm going to give an example of the problem we are trying to solve. Here we are trying to solve y equal ax. X is the input spectrum, and A is actually what we build in the hardware. It's called your sensing matrix, and Y is the output of the hardware, the spectrum sensor. And here Y has a dimension of m, and X is a dimension of n0. And m is significantly smaller than n0. So what does this mean? Compressed sensing makes it possible to recover information from fewer measurements than the unknown signal values. So you only need, let's say, 8 measurements, m is equal to 8, and n0 is equal to 50, to cover 50 unknowns. So you are solving an underdetermined system of linear equations, but that would normally have infinitely many solutions. How do you find the solution to your problem? Is you assume sparsity. You start with the prior assumption of sparsity, that you have 3 maximum interferers out of 50 bins, and that helps you to find the unique solution, which is the sparsest solution. How does it work? So what happens is the CS measurements, compressed sensing measurements, are non-adaptive linear projections onto an incoherent basis, which is your A basis, with the basis that your signal could be defined as sparse with only a few non-zero coefficients. So to identify your signals, what you do is, when you're working in the signal processing side, you look at which columns of this A matrix, the sensing matrix, participate in the measurement vector Y. So you look for the strongly correlated columns of the A matrix with the Y, and then you subtract off its contribution, and you continue on you iterate on the residual. So the idea behind the algorithm is to pick the columns in a greedy fashion, and at each iteration you look at the strongly correlated columns between the Y and the A. After m iterations, the algorithm will identify the correct set of k columns. And typically this A provides you better signal recovery guarantees if the A is a random matrix. Why is that? Because if you look at this problem, I'm showing with red actually the signals. So let's say if I had one signal that I'm trying to recover, and that's at the second column, it's corresponding to the second column of the A matrix. It's easy to do in a lower dimensional space, right? Basically, you're reducing the dimension. You have many unknowns, but a smaller set of equations. It's easy to figure out if you only had one signal. If there are 2 signals, it's harder to distinguish between those signals at a lower dimensional space. If you have 3, it becomes even harder. So you have to select this A matrix and build that to provide incoherent measurements. This A has to be a random matrix, and this incoherent measurements allows you to be able to distinguish between those signals in the lower dimensional space. So how do we implement these incoherent measurements in hardware? That's the challenging part. Typically, this is the matrix form you're seeing on the top. So you have the Y measurements. This A matrix is formed by pseudo-random noise sequences for this purpose, and X is the input spectrum. And the hardware equivalent of that, if you look at only one of the dot products between the ith row of the sensing matrix with the X measurement, X input vector, you see the hardware of that. So you have the X coming into the bottom part of the slide, you have the hardware. X is coming into the mixer. You mix it with the pseudorandom noise sequence, and then you filter out to get one of your measurements in the time domain before you sample with the ADC. So what's unique about these PN sequences, you see the time domain waveform on the top. It consists of deterministic sequence of pulses that repeats itself after its period. But what's interesting is actually their frequency domain. Unlike the signal of interest, the X, they are not sparse. They're actually very dense in the spectrum. That's what you're seeing, their spectral response in the frequency domain. So what happens when I mix these two things together? So you're seeing the PN spectrum, the black one, and there are the input spectrum X is shown with the green and the red that we want to capture. So they're overlaid together. When you mix them, you spread the spectrum, right? You create multiple copies of the spectrum because you're mixing with all those frequency components. But you also alias the information from all the spectrum bins onto each bin. So you have alias copies of the spectrum. When you have a low-pass filter, you have only one copy of this alias spectrum. So normally you cannot really distinguish between the alias information, but you use compressed sensing to be able to distinguish between that alias spectrum components that are folded on top of each other. And why we are aliasing? Because it allows you to sample at a low sub-NICUS rate. So this is actually a sub-NICUS sampling approach. And I'm going to show you how it is done traditionally. So this is one of the architectures proposed by actually one of my collaborators, Eldar, Janina Eldar, and she proposed modulated wideband converter in collaboration with Stanford with Boris Merman. And what they do here is it's called the low-pass CS approach. They capture a spectrum from DC to maximum frequency of interest, let's say 3.7 gigahertz. There's an LNA. After that, they mix the signal with high-rate pseudorandom pseudonoise sequences, and these pseudorandom noise sequences are operating at the NICUS rate frequency of the entire bandwidth, and then they have low-pass filters to get that one alias copy of the spectrum. Now you can sample at the sub-NICUS rate, so they only sample at the resolution bandwidth rate. Let's say if you're capturing a gigahertz of bandwidth, you have to have the pseudorandom noise sequence at the NICUS rate, but the ADC can operate at a low frequency of in the orders of 20 megahertz, which is your desired resolution bandwidth. But the challenge of these structures traditionally was that this pseudorandom noise sequence has to operate at very high frequencies in the orders of tens of gigahertz, which was making it the most power-hungry block to generate those sequences. And the other challenge is there is an inherent noise folding. What does that mean? What you're seeing in the bottom is how actually this architecture captures information. So there are multiple signals, and when you mix with a PN sequence, you are folding, aliasing that information. While you fold the information, you also fold the noise, which degrades the sensitivity of these systems. But in this structure, in the low-pass CS approach, there is an additional noise folding coming from that DC to 2.7 gigahertz. What was our scenario was we want to capture 2.7 to 3.7. But there's this additional part that you don't have any interest information, but you are actually folding noise, which degrades the sensitivity. And we collect multiple measurements, incoherent measurements, that are less than the number of unknowns. And we, in the backend, we do compressed sensing recovery to locate those signals. So what we propose is called bandpass compressed sensing. What does this do is this is an architecture called quadrature unlocked information converter. It only captures the 2.7 to 3.7 gigahertz interest bandwidth. So even though we are only interested in that gigahertz of bandwidth, by introducing a wideband RF IQ down converter, we limit the bandwidth to only to that gigahertz of range. So after the down converter, now you're operating at baseband frequencies. So your PN sequence, rather than operating at 10 gigahertz, it's only operating at 1.26 gigahertz, which is a NICUS rate of half the span frequency. And this structure allows us to save a lot of power, as well as you can also reduce the hardware branches that's coming from the length of the PN sequence, but I'm not going to go into those details right now. Of course, it also helps with the sensitivity. Now you're only folding the information and the noise from the interest band. There is no additional noise folding that's coming from DC to minimum frequency. So this allows you to capture multiple measurements again, and it provides better power consumption with 9 dB better signal sensitivity, with reduction in hardware branches and lower aggregate sampling rate compared to low-pass CS approaches. This was a full system demo that we built from all the way from the signal generator to the chip and to the backend. And I'm going to show a couple of measurements before we come to the end of the talk. So here on the left side, you're seeing the wideband interfere detection. It can detect 3 interferers across a gigahertz of wide spectrum that can be anywhere in that gigahertz. Here you see the input signal spectrum as the black curve, and the red signal is the reconstructed spectrum. And we have 3 interferers at 2.76, 3.54, and 3.58 gigahertz. And it can detect these very fast in 4.4 microseconds, which we are going to look at with the measured result. So these are all measured results. And you can actually change the resolution bandwidth of these systems from, let's say, 20 megahertz to 10 megahertz. That allows you to capture the spectrum gaps, as you can see here. So if you had 10 megahertz signals with 10 megahertz gaps, if you look at it with 20 megahertz resolution bandwidth, you will see them as adjacent channels. If you change it to 10 megahertz resolution bandwidth, you can figure out the spectrum gaps. And on the right side, you are going to see the time agility. I said these are fast detectors, so let me show you why. On the right side, the top curve, you are seeing the input signal spectrum with a 3D plot with frequency, time, and the power axis. At the first instant, you have the red one, which is a single tone at minus 42 dBm. And then in the second time instant, there's the black curve with 1 signal and 2 noise-like band-limited signals. On the bottom plot, this is the input signal spectrum. So the detector doesn't know anything about this signal. And on the bottom slide, bottom plot, you see the QIC baseband output signal that's captured on the scope. QIC output is changed from single tone to 2 band with a tone at the output. As you can see, it starts with a single tone structure, and it has this noisy structure when they're aliased together. You also see this digital-like waveform that's going from low to high, and that's actually telling us, the users, when the signal support change command go from low to high, that tells us the instant that the input spectrum is changed. And we see that how much time it takes for the QIC to respond to that change. You see that there's only 0.4 microseconds, which is the detector response time. This comes from the settling time of the baseband filters. And there's also the signal processing time. So we actually collect 80 samples at 20 megasample per second rate. So the scan time total is 4.4 microseconds. This was implemented as well, and you see the detection probability and the false alarm probability versus power per active frequency bin for 1, 2, and 3 interferers. And it can achieve with 3 signals a sensitivity of minus 68 dBm per 10 megahertz signal with a detection probability of 90% for those 3 signals. Actually, above 90%. So if we compare with the traditional solutions one more time, for the same settings, traditional solutions require 220 microseconds of a scan time. So this is 50 times faster. It only requires 4.4 microseconds. This allows us to save energy and 50 times faster tracking of dynamically changing interferers in a wideband spectrum. It can reduce the hardware branches compared to a multi-branch sensor by 6.3 times and reduce the aggregate sampling rate compared to an IQOS rate architecture. But of course, it has some limitations, right? So we can compare it with respect to a multi-branch sensor. They have the same scan time, fast, 4.4 microseconds. You only need 8 branches, not 50, so you reduce the number of branches to capture the spectrum. So it provides a very fast response time with smaller hardware, which allows it to achieve also lower energy than any traditional spectrum scanning approach, almost to an order of magnitude or 2 orders of magnitude. But the limitations is this noise folding we discussed, which limits the sensitivity. And you might have already noticed it requires sparse signals. But it's still quite well suited for the interferer detection application, because you're only looking for large signals, right? Noise folding does not really affect because you're not looking for weak incumbents with this technique. And as I said, it requires sparse signals, so hopefully your interferers are only few, not too many. But of course, you cannot really guarantee that. One challenge in implementing these CS systems is you start with an assumption of maximum sparsity level. And that actually sets the number of hardware branches in your system. So this K0 term in this equation is the expected maximum sparsity level, which sets how many hardware branches you have to collect incoherent measurements. I said we have 8 branches because we only need to detect 3 signals. But what happens if once in a while the spectrum becomes densely occupied, right? What happens if there are more signals? Actually, unfortunately, these CS systems fail in detection. They become unreliable. As you can see, the detection probability goes down to 50% as soon as you change from 3 signals to 6 signals. So to overcome this, we developed content-aware signal processing, where we do sparsity estimation and adaptive thresholding in the backend, and we virtually adapt the hardware through time segmentation to adapt, and that way these structures can perform reliably under dynamically changing sparsity conditions. Even though I'm not going to go into details of these techniques, we play tricks in the signal processing to estimate sparsity and adaptively threshold. And we also played on the tricks on the hardware side to adapt and collect time segmented measurements. Just to give you a slight example, so if you look at the virtual hardware adaptation, if I wanted to detect one signal, as you can see on the top part of the slide, you need 3 hardware branches, 3 incoherent measurements. Each incoherent measurement is corresponding to a hardware branch in a traditional implementation of compressed sensing. But let's say you want to save power, so you only use 1 branch. What you can do is over time, if you can actually do sparsity estimation in the backend, even though you're a blind spectrum sensor, you don't know anything about the sparsity in the beginning, you start with an assumption and you build 1 single branch. You can adapt the hardware by changing the incoherent measurements, which means that you're changing the PN sequence you're using across different time segments. So here what happens is you start from T0, T1, and T2, you collect incoherent measurements over time segments. Of course, you have to make an assumption that your signal spectrum is pseudo-stationary across these time segments. But thankfully, this CS architectures are very fast, right? They're operating at 4.4 microseconds. Hopefully, you can guarantee that your signal is actually pseudo-stationary across those quick scan times. This was also implemented on a chip, and there are some references if anyone is interested, but I'm not going to go into details given the time. And I just want to show you that actually it can go to very high detection by using this time segmented technique, even though spectrum density, it becomes dense once in a while. Before we end, I'm just gonna walk you through just with a couple of words on some of our ongoing work without going into details, and then we can end. So these are some of the ongoing work. Today I didn't present some of them because they are still currently getting published. So hopefully next time I will talk about those ones. But just to give you an example of applications, this was the terahertz cryptographic tag work. It aims for, it's like very small packageless terahertz identification tag with high security. It's to mitigate counterfeiting with reduced form factor and reduced cost due to packaging. One of our target area for this technology is actually against pharma fraud. Currently, counterfeit medicine count for the 10% of the global medicine trade, and current approaches either require holograms, shift inks, and color shift inks, and they can actually easily be duplicated. Or people use RFIDs, but they are large and their cost is still too high. So you can put them on a medicine package due to their large size, but it's still possible to illegally reuse or refill the packages. Now imagine that you can do pill-by-pill basis authentication, or you can maybe authenticate actually COVID vaccines, right? There's been a lot of counterfeit vaccines as well. Or this can be used for verifications against counterfeit IC chips, which affects the semiconductor industry, because currently counterfeit detection of these ICs is done through physical inspection, X-ray imaging, or electrical testing. They lead to excessive time and cost. Now you can envision that you have this very tiny packageless identification tag that can be integrated with your chip as well, without actually, it can be embedded together with encrypted data tracking of the production and the trade history of the chip. Because most of these counterfeit chips comes from recycling. So you can actually avoid that by using these type of secure tags. There are different applications like counterfeiting, anti-counterfeit of banknotes, medical components like tooth implants, everything that you can think about. So we call it tag of everything. This works at terahertz frequencies. Actually, terahertz is not used mostly for communication and sensing in this work. It's used for wireless powering. The small wavelength allows you to achieve full integration of including on-chip antennas for data transmission and energy harvesting. And this was one of the first integrated cryptographic terahertz tags. It is tiny like a particle. It has smaller volume than 0.1 millimeter cube. And it actually has a fully integrated cryptographic processor, which can operate from this harvested energy from the terahertz. We have done a first demonstration with an optical power as well, and the terahertz tag only consumes around 10 microwatt of power. And we are also doing some work with Runan Han and Ananta Chandrakasan at MIT to look at physical layer security resource directions by leveraging the physics, such as the terahertz signal directionality and their high spatial sensitivity and polarization of EM waves, but I'm not going to go into those details. In my group, we also do some work on the ingestible capsules. These are for GI tract monitoring to help with Crohn's disease or other disease related to the GI inflammation, gastrointestinal tract inflammation. So here, this is a capsule that you swallow, and it actually detects the, for example, stomach bleeding or other GI-related health disease biomarkers. And it does this with the help of synthetic biology with our collaborators, Tim Liu. And we have electronics that detects the light coming from synthetically engineered, genetically engineered bacterial cells. And we transmit that information of biomarkers or the stomach bleeding to the outside of the body. So we design very low power circuits, and they package together as a sensor pill with the help of our collaborator Giovanni Traverso. So what's key about this system is there was a first prototype by my collaborators, but it was very large, 3 centimeter by 1 centimeter. As you can see on the left side, the capsule, probably you don't want to swallow that. So we have a newer version that my students, actually including Arsan, one of your graduates who was working on this. This new system is very small. It's at the millimeter scale. That makes it easier for clinical trials. And it is integrated fully with multiplex measurements. So there are multiple arrays of measurements to be able to simultaneously read out multiple analytes. And what's interesting is it consumes only nanowatt level power. So it's very, very low power, because we envision that in the future it can be fully operate in energy harvesting environments within the GI tract as well. So unfortunately, I don't have time to go into this work. We also have some secure drug delivery work with Unlock Devices in collaboration with Unlock Devices Incorporation and MIT again with Ananta Chandrakasan's group. This work is focusing on future drug delivery systems that uses a cell phone to control the drug delivery for an embedded drug delivery system. And there are some security challenges because the cell phone is the relay in the communication between the physician, user, and the IMD. And the challenges IMDs are very low power, right? They don't have enough resources to do high computation or communication. So you need a mechanism to make sure that you can securely communicate with the IMD if someone actually creates, if someone attacks the cell phone, which is the relay, right? If your cell phone becomes malicious, how do you make sure that someone doesn't trigger your direct delivery system? So we created this, what you're gonna see is there was no communication between the user and IMD. In this work, we created communication through a human voluntary signal, a touch-based, tap-based sensor to create communication between the IMD, and we propose a dual-factor authentication. This is similar to the bank accounts, right? You typically have a password, so we have a first-order, first-factor authentication that's coming from traditional cryptographic operations. And we also have a second factor, which is coming from a human voluntary action to create a link between the user and the IMD. But if you're interested in, we have a paper on this at CICC last year, as well as we talk about this work in our SSCS magazine journal as well. So to end my talk, we discuss a couple of different projects. We talk about system level approach for secure wireless communications and spectrum agility. We also talk about some of the future directions and current ongoing work in my research group, and hopefully you will get to read most of these publications in the new year. And with that, I also would like to acknowledge the funding sources. Hong Kong Innovation and Technology Fund, who funded the secure wireless communications work, Texas Instruments, NSF Unlock Devices for funding support, TSMC University Shuttle Program, and ST Microelectronics for chip fabrication support, and Helmsley Charitable Trust for the ingestible biocapsule work. And with that, I would be happy to take the questions you might have. Thank you.
Thank you very much, Dr. Rabia, for a very detailed and very informative talk. You covered a lot, many things related to secure wireless communication, spectrum-aware wireless communication, as well as some of your recent ongoing work. So I'm very sure our students who are listening to your talk in the seminar hall and the one who are attending in live, they get a lot many information and food for thought and maybe for future directions as well. I'm really thankful to you for your time, and I mean, actually joining us so early in the morning. I know in Boston it must be very early now, so I'm really thankful to you for this session. So I know you may have short time, but we have so many questions. If I can ask few of the questions, sure. Maybe.
Sure.
So from the secure wireless communication, you talked about the bulk acoustic wave devices, and based upon that, this structure that you have made, and also about the physical layer in encryption that you have shown. So one of the questions is that already the encryption, there is a lot of encryption, but that is on the higher layer, that is not at the physical layer. So how do you compare actually working on the physical layer encryption? Because eventually that is going to make the hardware very complex as compared to the one which are already available now, where the encryption is at the higher data, higher layers.
Oh, no, that's a very good question. So that's a system level question. And what we're claiming with this work, actually, as I mentioned, we have the tutorial type of paper. I would really recommend to students, especially to take a look at the SSCS magazine paper in the fall 2020. What we do is we don't claim that the physical layer security will replace the higher layer security, because it should be actually like an additional layer. Going forward, for IoT devices, you actually need security across multiple layers of the stack because of the attack models. Because even though, so there's higher layer encryption, but in this scheme, what we did with that pseudo random selection based FSK modulation, that was actually helping us, first of all, to protect against the attack of selective overriding, but it came for free in a sense with this physical layer encryption. That was an additional layer of encryption. But yes, these security mechanisms in the physical layer will cost you something, which is true. But currently, unfortunately, there are also attacks in the physical layer, not only at the higher layers that you can address. Some of those, for example, selective jamming type of attacks, there's no way that you can address in the software layer or other layers through higher layer encryption. You need some of these techniques to protect at the physical layer too. But they are not actually replacing the higher layer techniques. They're just additional to those techniques. They come at the cost. If you ask for that work, for example, the entire chip consumes 10.9 milliwatt, but that's still on the low power side for BLE type of transmitters. And the security part is consuming around 1 milliwatt of power. So that is the cost that you pay to get security. But unfortunately, going forward, we have to start designing our systems with security in mind, right? Because there's a lot of attacks that's coming from the connectivity of devices. And that's one of the, I would say, the interesting research fields. People are looking at more now at the RF analog level. How do you provide security? Because that's the weak point in the system, right? There's a lot of work in the digital security as well, and that's very well characterized. It's hard to characterize RF analog security. That's one of our actually recent projects that Arsenal is involved with, Analog Devices Incorporation. We are looking at how do you define RF analog security? What are the mechanisms to protect in the RF systems? Of course, they will cost you something, but hopefully you can provide some additional layer of security.
Thank you very much. About the spectrum-aware wireless communication, one of the questions is it something, the same concept which was proposed in the cognitive radio? And if so, why is, I mean, because that is a fairly old concept, and why is that not been able to come into the market? And what are the main challenges?
That is a pretty good question. Actually, currently, I recently become a part of a center, NSF Center. We are actually working on a NSF Center planning grant. NSF recently announced the spectrum. I mean, we don't have the center yet. Hopefully, in the future, if it gets funded. But let me tell you that it's a very big problem in the whole world. I would say also in the United States. How do you provide spectrum efficiency, especially with all this increasing wireless data traffic? And cognitive radio is one of the old concepts. Yes, that's very true. And you will see in the circuits world that there's a lot of old concepts that comes back again, right? Even machine learning, it's now very hype, but it was a concept from back in the time, but it just became feasible now. So it's still not in the market, but there are better solutions now that people are looking at. How they achieve spectrum efficiency, and this is not only again at the one layer. We are looking at from the hardware perspective, but there are people working at the network side. We have collaborators working at the also the regulations of the spectrum, right? It's not just one person or the one field would enable this, because I think there is a lot of system aspects to it that has to come from different people with different backgrounds. So from the hardware perspective, now these cognitive radio type of things became more feasible because we can build hardware that's more power efficient. We can build hardware that can take wider bandwidths, right? We are designing ADCs now that can capture several gigahertz of bandwidth, which we weren't able to do before. Now people are looking at higher frequency bands as well. You have openings at the higher frequencies, which you can use at like several gigahertz, like 25, 30, even 70 gigahertz to be able to deploy some of these solutions. And the example I gave was at 2.7 to 3.7 gigahertz, but that doesn't mean that it's only applicable to that band. That's just a concept, right? Just a theory and the feasibility study, and it can be hopefully taken from research to the next level to be applied to different frequency bands as well.
Thank you very much. So one of the questions is about the role of machine learning and artificial intelligence in the spectrum sensing and security application, which you discussed. So is there any further extension and role of machine learning and AI in those works?
Yes. I don't work too much in that domain, but I actually have recent collaborators. We are looking at, for example, MIMO systems with Professor Yoni Naldar. She is well known in the signal processing side. And we are applying deep neural networks to some of our problems that takes advantage of the task we are trying to perform for MIMO systems. There is some level of machine learning interaction there. Of course, from the security side, there's we are looking at homomorphic encryption, which is important for machine learning tasks, to be able to perform operations, computations without decrypting the data, so you can perform it on the encrypted data. There is some role of machine learning in every area now, because it's also one of the hot topics in a sense. Yeah, I mean, I'm sure you can apply it to some concepts that you can learn and gain from that technique as well. But it's not one of our center topics, I would say.
Right. Thank you. Let's have one last question. So one of the audience is asking that, can you please explain the clinical trial method for ingestibles?
Yeah, currently we haven't done the clinical trials. So far we have been doing animal studies with the help of my collaborator Giovanni Traverso. He is a medical doctor, as well as he is a professor at MIT in mechanical engineering. So he helps us encapsulate these electronics with the bio side, with the synthetic biology. Hopefully in the future we're going to do clinical trials, and that time hopefully I will have more information. I mean, bio is a new field for me. Since I moved to BU, Boston University, I have more work together with the biomedical engineering department at BU as well as MIT. So I don't really know how clinical trials work in the United States so far. We are in the early stages where we do in vivo studies with pig or other animal models.
Once again, thank you very much, Dr. Rabia, for your time and for such a detailed talk and the question answer session. One interesting thing to note here was about the your ongoing project. I can see that one of your co-authors is also the alumni of our university. So I believe that is a point of motivation for our students, that if they work hard, they can certainly apply to you in future for the PhD position, for MS positions.
Both Arsan, my student, as well as Mohammed Ibrahim Khan, I guess he is also from the same university. He is working with Runan Han at MIT. That's actually one of the co-authors of this terrorist ID work, which we published at the ACCC, and now we are we also publish at GSCC. So yeah, I've been collaborating with a lot of students from your school, and they all come with a very strong background.
Thank you very much for your time and this talk, and we hope to have you maybe in future as well when you host such a conference here. And once again, thank you very much, ma'am.
Thank you. Thank you for inviting me, and I'll be happy to have applicants, of course, for my group from your school as well. Thank you.
Yeah. So with that, we almost come to the conclusion of our today's session on IEEE seminar on women in circuit and system. So we had two very informative talks by Dr. Wala Salim Mustafa and Dr. Rabia. And at the end, I'll request Principal RIMS to give his concluding remarks.
Dr. Umar, I cannot hear you.
So thank you very much again for all the attendees, and I hope it was a very informative session for all of us. So in the end, I'll request Principal RIMS to share his thought about this event and say a few words.
Am I audible and live?
Yes, so now you are live and audible.
Okay, thank you very much, Dr. Umar. So I'll not take much time. I think it was a long session today, So, but few thanks and appreciation is due. So, honorable speakers, RIMS faculty members, seminar participants, and dear students, Assalamu alaikum, and a very good evening to all of you. It is a pleasure to join you in this seminar on women in circuits and systems organized by Research Institute for Microwave and Millimeter Wave Studies at National University of Sciences and Technology. I hope that all of you had a fruitful learning and motivational experience through the technical talks as well as the panel discussion. Let me first pay my gratitude to the worthy speakers, Dr. Vala Sadeh and Dr. Rabia Tuje, who very kindly accepted the invitation at a very short notice, and that too at the onset of the upcoming holidays. I would also thank the participants of the panel discussion, Dr. Simab, Dr. Sana, Dr. Mohera, and Ms. Akila, for their thoughtful comments and being role models for the next generation of women engineers and scientists. The seminar would not have been possible without the gracious financial support of the IEEE CAS Society. A special thank you to Professor Yoshifumi Nishio, who supported and encouraged the chapter to organize this event. In the first technical presentation, Dr. Vala from LUMS shared her fascinating work on systems on chip solutions for non-invasive glucose monitoring and anesthesia detection through biomedical devices. It was heartening to see the cutting-edge research being done in Pakistan, which can potentially help a large number of people in the healthcare sector. Dr. Rabia Tuje from Boston University just concluded her talk, and she shared her vision for future wireless communication. And it was enlightening to see the variety of applications that once seemed science fiction, but with the rapid development in circuits and systems are becoming a reality. The Women in Circuits and Systems theme of the seminar is part of a larger movement to recognize, celebrate, and encourage females in the science and technology domain. Women in Microwaves, abbreviated as WIM, is another similar initiative under the umbrella of the larger Women in Engineering, the Y group. In my opinion, having more women in engineering and specifically circuits and systems can provide more weight to the unique perspectives, vision, and ideas women can bring along with them. This includes empathy, creativity, simplicity, and selflessness, to name a few. I hope the seminar participants, especially the young females who are just starting their careers, benefited immensely hearing from the successful role models and got a huge motivational dose to excel further in their careers. In Pakistan, women population is 52%, thus outnumbering men to some extent. However, their presence in the science and technology arena is a meager 7 to 8%. So therefore, we need concerted efforts at all levels to boost this percentage for the betterment of society at large. Research Institute for Microwave and Millimeter Wave Studies at NUST aims to become a center of excellence in the RF and microwave domain at the national level. With a focused graduate program, well-equipped lab facilities, and a strong collaboration with local industry and foreign universities, we aim to carry out cutting-edge research and link it to the local challenges we face today. The student body at RIMS consists of more than 30% females who are being provided all the opportunities to dream big and become leaders in the RF and the circuits and systems domain. In the end, I would like to commend my RIMS team, including faculty members and support staff who took a leading role in organizing this international seminar on women in circuits and systems. Like the many firsts in the past, this was also the first of its kind event from the Institute's platform. The chapter chair, Dr. Noshirwan Shoaib, needs a special mention as he took up the challenge of curating this webinar with a deadline of 10 days only. And with able support from everyone, this became possible. On behalf of RIMS and NUST, I would like to extend best wishes to all of you for the new year and hope that we are able to overcome the COVID-19 pandemic together and meet in person next year on similar events, inshallah. Thank you very much, and Allah Hafiz. Dr. Umar, you're not audible.
Thank you very much, sir, for your kind words on this event and your concluding remarks. So with this, this event ends. I thank all the participants for their participation, and I hope it was a good event and a source of learning for everyone. Thank you very much.